Hello, can you hear me? Hi everyone, just let me know if everything is fine. Just let me know if you can hear me. Okay, so everything is fine, right? So audio, video, everything is fine. Once you confirm, then we will just start. Okay, just let me know if your audio is fine. Okay, so Abhay is saying hi. Okay, hello Abhay, how are you doing? Let's get started. So we will see, AIMT three solutions of this year, Gate DA. Which means that whatever questions we have already put in AIMT, so most of the question solution we will see. Okay. So before I start, just let me know how was your marks, if I can ask this question to you guys. Okay, how was your marks? How well you did in AIMT? Just let me know. How was your marks? Okay, so let us see if there is some interesting response. Okay, so yes, I mean, if you are not comfortable, then it is okay. So Abhay is saying he got 60 out of 100. That's really nice. Okay, so we will be solving most of the questions, and then we will be understanding each question in a good detail. Okay, if there is any confusion, you can definitely ask. Okay, in between also, and you just let us know in the comment, and then I will be keep on checking comments, and then I will be answering from the comments. Okay, so let's see this question. This question is related to mean mod median, right? So it is kind of a statistics question. So how many of you were able to solve it? Just let me know. And what was your answer of this particular question? So this is question number. Okay, number is not important. I mean, it might be shuffled in your test, but yes. So this is question which was related to mean mod median. Okay. So how many of you were able to solve this question? And what was your answer? Yes. So answer was actually A, right? So what this question is saying? This question is saying that what about mean, median, and mode? See, mean is something you will say it is just a center, right? I mean, you will if you have observed that these are the probabilities, so you can understand these probabilities like a frequency. Okay, so since it's discrete probability mass distribution, you can understand like a frequency, which means you can say that minus 13. Okay, see these probabilities you can understand like probabilities like frequencies. Okay, which means which means this minus 13 probability is, let's suppose, some, okay, I mean something, right? Then let's suppose 0.5 or something, right? 0.6 or whatever, right? So this minus 13 probability, if that is the probability, or let's suppose 0.3, okay, if that is the probability of minus 13, then you can say, okay, it has come out of 100, it has come 30 times. Okay, 30 times if probability is 0.3. If probability is 0.3. Okay, you can understand these things as a frequencies. Now if they're asking about the mean, it means that they're or let's just first talk about the median. If they're asking about the median, it means they are saying that number of people on the left and number of people on the right should be exactly same. So median is very clear, this is 0, right? So median, I mean, whatever is this number, I think this is 0 only. So median is very clear that median is 0, right? Because number of people on the left, if you treat them as a frequency, then number of people on the right are same, isn't it? Is this okay to you everyone? Right? So that is why you will say median is 0, or median is this, right? This is median. What about mean? Mean is average. So since you observe here that here is minus 13 and it is symmetric, right? It is symmetric. If you take the average, weighted average, right? I mean, or the expectation, if you take the expectation, then it will be 0 only, because expectation is basically nothing but the weighted average. So since this is minus 13 and this is 13, right? So you will see that, okay, if you take the average of this, then since these numbers, I mean, or these frequencies are same, so you will see that, okay, average is also 0. So you will be convinced that mean or average is also 0, right? So mean and median is same. And what is mod? Mod is something which is highest, right? So mod is something which is having the highest probability or the highest frequency. Okay, highest probability. So here the mod is minus 13 and 13, these two numbers are mod. Okay, so here if you ask me the mod, then minus 13 and 13, these two numbers are actually mod, which are having highest probabilities. So that is why mod is different. Mod is minus 13 and 13, right? And mean and median both are 0. So that is why A is the correct answer here. Understood? Okay, that's great. Now let's move to the next question. In this question, they are saying the probability density function of a continuous random variable, okay, x and y is this. So that's easy. Since y is greater than x, so you will say they're asking about the uniform random variable, right? So if you observe in the uniform random variable, you have the uniform PDF, right? Probability density function, it should be uniform in certain range. So xy is the range which is given to you, and it should be like this, right? It should be like this. They are just asking about this value. Let's suppose this is c. Then what should be the PDF? So PDF will be basically c in this range, right? If this is basically uh, this range x comma y, okay, it is c. Otherwise it is 0. Okay, otherwise ow means otherwise. So basically they're just asking the value of c. So you know that this area should be 1, right? So you will observe here, this is length is y minus x. So since you want the area to be 1, so c into y minus x, you want this to be 1, right? This to be 1. Hence c is 1 upon y minus x. Is this okay to you guys? Okay, great. Now what is the correct answer? So B is correct answer here, right? Let me know if there is any confusion here. Let me know if there is any confusion. So B is the correct answer here. If there is any doubt, you can just quickly ask me. Now let's move to the next question. If there is no doubt, then we can move to the next question. This was question which was related to stack, right? So what they are saying, there are 5 items A, B, C, D which are in a stack, and one after another. And one after other starting from A. So they are saying starting from A, one after another. They are stacked up, right? A, B, C, D, E. The stack is popped 4 times, and each element is inserted in the queue. So the moment you pop it out, then you are inserting in the queue, then D, then C, then B, like this, right? The 2 elements are deleted from the queue. Okay, if you delete it, then these 2 elements will be deleted and pushed back on the stack. So once you delete it, okay, so basically E, D, C, right? C and B are moved away. Once you delete it, E will be here and then D will be here, right? The popped item is, now one item is popped from the stack. So can you tell me what is the popped out item? What is the answer of this question? Let me know. That's very easy, right? So it should be D, right? So if you pop from the stack, then it should be D. So which means D is the answer here. Okay. Understood? Okay. Now let's move to the next question. Okay. Let's see what this question is saying. So they are talking about that there is some Python function which is given to you, and then they are saying what will the output of this code when it is executed, right? So when you execute this, then what is the going to be what is output it will produce. So if you observe here, then this is a function which is calling f2, right? It is having a recursive call. See, for f2, if you call, it will be executing recursive call. So let's just execute it. So f2 will say that, okay, let me first print a. Okay, so it will print a. Then if n is greater than 0, since n is greater than 0, it will call f1. And then once this is completed, right? Once this is completed, it will basically print. What it will do? Tell me. It will print b, right? Once it is completed, it will print b. Okay, pb means it will print b, or if you want, I can just write print, right? And so first you will print c, because c is outside the function. So first you will print c, and then f2 will get called. Okay, then f2 will get called. So c, and then everything else is happening. So here first f1 will happen. So for the f1, you will say since n is greater than 0, you will call f0. You will print a, by the way, you will print a, and then you will call f0. And then once f0 is done, then you will print b. Okay, you will print b. Now f0, for f0, since n is not greater than 0, you will only print b. You will only print b. So it will just print b and then 2 more times b. So ca triple b. Ca, have I missed one a? Uh, so since you're calling, yes, since you're calling it 3 times, it should be 3 times A. Okay, for F0 also, it will print A first, right? For F0, for F2 it will print A, for F1 it will print A, for F0 also it will print A. So it will be 3 times A. Understood? So let me know if there is any confusion here. It is easy question, and what is the answer here? D. Right? D is correct answer. Okay. Now let's move to the next question. Next question is related to warehousing. Okay, it is related to warehousing. In data warehousing, there is a concept called normalization. Okay, and they are asking about the same concept. If you observe official syllabus, there also this normalization concept is actually mentioned. So let's just solve this question. It's very easy question only. Now what they're saying, you have to normalize this 65,000. Okay, so the 65,000 they're asking to normalize. Now, if you observe, then the values, the minimum value, okay, they are asking about the min max normalization. So the minimum value is 45,000, maximum value is 85,000, right? This is minimum, this is maximum. Now what they are asking you, they are saying that can you normalize 65,000? So what you need to do, 65, okay, since 1000 is common, so you can have 1000 later on also, minus minimum divided by max minus min. Okay, so max minus min. So what is the max? Max is 85 minus 45, right? So max minus min is 85 minus 45. So if you do it, you will be getting 20 divided by 40, which is 0.5. Okay, so that's very easy question. So this is the formula, right? This is the formula that we do for min max normalization. If you want to normalize any value v under 0 and 1, okay, max minus min, x minus 1. If you want to normalize under 0 and 1 only, then this is the formula that you will be applying. Is this fine to everyone? Okay, great. Now let's just see this. The graph of the function is shown here. Fx with a valid probability distribution function, the value of h is, okay. So now they're asking the value of h. Okay. So see here, this is one area, this is another area. I mean, you just need to make sure that all of these three area are summing up to the area of all of these are summing up to 1. This is the only thing that we need to make sure here. So if you solve like this, then what is the area of this? Can you tell me? Yes, so it will be, since length is just 1, I mean each of this having length is 1, so it will be 1 by 2 into base into height, right? Because it's a triangle. Okay, it's a triangle. 1 by 2 into base into height. So 1 by 2 into base is 1, height is h, plus 1 by 2 into, so you can take 1 by 2 common, base is again 1, okay, into height is 2h, plus 1 into 3h, right? So it will be h plus 2h plus 3h, 5 and 1, 6h, right? So 1 by 2 into 6h, this should be 1. Is this okay to everyone? So from here you can find out 3h should be 1, so h should be 1 by 3. Is this fine? So that is why this is easy question and A is the correct answer here. Okay, great. So most of you people have done this correctly. Now let's just solve this question. What this question is saying. Here you have x and y random variables such that E of or the expectation of 2x plus y is 0 and expectation of x plus 2y is 33. Okay. So basically expectation of 2x plus expectation of y. Basically you can take this expectation inside, because you for the expectation you don't need the variables to be dependent or independent. This is always true basically. Okay, for variance you need independence, but for expectation linearity always hold. Okay, for expectation linearity always hold. And here you have ex plus e of 2y equal to 33, right? Is this understood to everyone? Let me know that how we are writing these things. So once you have this, I think now it is very easy. How? You can just solve. See, this 2 will come outside because of linearity. So it is like 2. I mean, I'm not writing x. If you want, you can write x. So it is like 2x plus y equal to 0. It is like x plus 2y equal to 33, right? So if you solve this, then you will be getting expectation of x and expectation of y. So here with the solution, you will be getting expectation of x as minus 11 and expectation of y as, if it is minus 11, then it is 22. Is this fine to everyone? Let me know. Right? So So if you sum this up, then what will the answer? 11 will be the answer. Great. Oh, Abhay is saying I did it correctly, but I typed instead of 11, I just typed 1. Okay, it happens. So that is the reason we are having AIMTs. Okay, so that you just make your silly mistakes in AIMTs and do not make those mistakes in gate. That is the only reason, right? Okay. So I hope that question is easy. Now let's just move to the next question. What next question is saying? They're talking about the variance. Okay. So variance of, I mean, basically they're not directly talking about the variance. They are saying expectation of x and expectation of x square. That is related by the variance. Do you know what is the variance of x? Can you tell me? It is expectation of x square minus expectation of x whole square, right? Expectation of x square minus expectation of x whole square. Since variance is always greater than or equal to 0, using this you can definitely solve this question, right? Because variance is always greater than or equal to 0. So it means the expectation of x square is greater than or equal to expectation of x whole square. Let me know if that is fine. Okay. Now let's just move to the next question. So in this question they are saying, if a matrix A has the eigenvalue this, then the trace is, okay, I mean they have given the eigenvalues has 1 as an eigenvalue. Okay, one of the eigenvalue is given as 1. So basically A plus 3 is trace, right? Or they are saying about both the eigenvalues. So I think from this question, what do you infer? So one of the eigenvalues is given, right? So basically we need to have two eigenvalues. Now what to do in this question? Let's suppose the second eigenvalue. Okay, so assume second eigenvalue is, let's suppose it is something as k. Okay, and one of the eigenvalue is given as 1. So what is the trace? So trace of this matrix A, it will be 1 plus k. Is this fine to everyone? It is basically sum of eigenvalues, right? And which is actually equal to a plus 3. I mean, it is also trace means it is a diagonal element summation. Okay, this is a summation of diagonal elements. So here, from here you got one equation. Okay, now can you get another equation to solve this question? See, if you find out the determinant of this matrix, it will be 3a minus 2, right? The determinant of this matrix. And this is same as product of eigenvalues, which is k. So 3a minus 2 is equal to k, and 1 plus k equal to a plus 3. So these are the two equations that we have got here. Is this understood to everyone? Now if you solve these two equations, then you will get k equal to 4, and if k is 4, then a will be, this is 5, a will be 2, right? Then a will be 2. Now what they are asking is trace. So trace means 1 plus k. Anyway, it will be 5 only, right? So it will be 5 only. So this is the correct answer. Great. Understood? Okay, one of the student is saying that AIMT 3 was quite simpler and AIMT 2 was dangerous. Okay, not, I don't think it was dangerous. Neither I think it is very simple. It is also, I think, containing 2 marks question, very conceptual, and that is what GATE does, right? GATE is also expected to ask 1 mark question easy on the easier side only. So that I just want you to have on the realistic measure. Okay, not too tough, not too easy, just on the realistic measure. So let's just see this question. What they are saying. A can be full rank even if there exist two vectors v1 is not equal to v2 such that a v1 equal to a v2. Okay, so a v1 equal to a v2. They are saying that a can be full rank even though this is happening. Is this possible? See here, from here you can say a v1 minus v2 equal to 0, which means this is eigen vector, right? I mean 0 is the eigenvalue basically, right? So it is ax equal to lambda into 0. So basically you can say 0 is eigenvalue. Okay, so 0 is, sorry, lambda into x. So 0 into x basically. Okay, ax equal to lambda x. Here lambda is 0, right? I mean, it is basically ax equal to 0. Ax equal to 0 means 0 into x basically. Okay. So instead of writing equal to 0, I'm writing 0 into x. So you can definitely say from here that lambda is one of the eigenvalue. I mean, determinant is actually 0. Okay, determinant is actually 0. So it means, can it have the full rank? Even if that is the case, it is an interesting question. Just let me know. In that case also, can you have full rank? The answer is no, right? Answer is no. So basically this is false. Let's just check this. A can be similar to identity matrix when A is not identity matrix, and also I have given the definition of the identity similar matrix, right? Recall that two matrices B and C are said to be similar if B equal to S inverse CS. So basically they are saying two matrices are similar, okay, B and C are similar if there exists some relationship like this. How many of you are goclasses student, and how many of you know that we have talked about similar matrices already? In the lectures we have talked about similar matrices. Even though I mean, you are not goclasses student, there are lectures on YouTube, okay, for linear algebra where we have talked about similar matrices. So anyway, now what they are saying is that two matrices are similar. Let's suppose this C is identity matrix, okay. So what is the similar matrix of this? If you find out the similar matrix, automatically it will be identity only. So B automatically has to be identity. If one of them is identity, then other one is automatically identity, right? So they are saying, but it is not always the case. No, it is actually always the case. So actually it is false. If this is an identity matrix, then it is similar to identity matrix can be similar to only identity matrix. Identity matrix is actually special, okay. Otherwise, two different matrices can be similar to each other, but identity matrix is special in the sense that identity matrix can be similar to its own only. To identity only, or its own identity matrix only. I mean, for any matrix, it is trivially true, okay, that any matrix A is similar to its own. Okay, any matrix A is similar to its own. For any matrix, it is trivially true. Or that is not the case. So maybe if you will this always be the case that any matrix is similar to I mean, a matrix is similar to its own? Tell me. What do you think? I think it is similar to its transpose or something. Okay. So or and there then also there are like some conditions. Okay. So yes, matrix is not similar to itself. I think if it is a square matrix, it might probably be a square and probably symmetric. I mean, I think there are some conditions using which you can say that okay, a matrix is similar to itself. This is square and symmetric, something like this. Okay. So, but yeah, there are some conditions for the similarity. I mean, if the matrices are similar, then you will be having okay four similar matrices. Similar as double L or single L. I think this is single L only. So the similar matrices. What are the conditions? Determinant is same. Okay, determinant is same. What else? Trace is same, or you can say eigenvalues are same. Okay, I mean, if you say eigenvalues are same, then automatically determinant and trace will automatically same. Okay, eigenvalues of A are same as eigenvalues of B. Okay, if matrices are similar. So this is most important property, that eigenvalues are same. Okay, this is most important property for the similar matrices. Yes. Okay. So someone is saying that thank you for your linear algebra playlist. Great. Sri Ram is saying he is Go classes student and a Gate regular student. Okay, Sri Ram. So now let's just move to the next question. So sorry, let's just complete this question. So this is not true. I mean, identity matrix is similar to its own matrix. It is not true that it can be similar to A, which is not even the identity. So it is not true. If lambda is eigenvalue of A, then there exists a vector x such that A minus lambda I into x equal to 0. So yes, that is true, right? I mean, that is the purpose. Ax equal to lambda x. That is the purpose of eigenvalue. So basically, this is true. So that is why C is correct answer here. Okay. Now let's just see this. What they are saying. Consider the matrix A and its row reduced equivalent form. So they have given the matrix and also they have given row reduced equivalent form of this. I mean, you don't need to do all of this. Okay. I mean, they have already given what is the row reduced equivalent form. Now, which of the following is or are the basis of column A? I mean, basis for the column space of A. Now, if you know that if you do the row reduction, okay, can you say this is the basis? See, this is the pivot column here. This is the pivot column. Can you say this is the basis? Can you say this? Tell me. Can you say these two columns are basis? After row reduction, you are getting something. And then can you say that these two columns are basis? The answer is no. Basically, this row reduction, I mean, you know, these two columns are independent, linearly independent, but you know, row reduction or row operations change the column basis. Okay. So this basis, I mean, basis of this and basis of this will not be same. At least you know that these two are linearly independent. So you can say these two forms a basis. So the very first option is actually confusing you. This is not true. This is not true. And this is a very interesting option. Okay. So 112, yes, this and 101. These two columns are bases. These two columns are definitely bases, but these two columns are not bases. This is important because row operations. Okay. So let me write it. Row operations change the column basis. Okay. So that is why this is not true and this is true. Since these are having just random 1, 2, 3, 4 dimensional vectors, anyway, this is not basis, right? And since this is basis, if you include anything else, right, it will span the column space, but actually it is not the basis because it is having something extra. This is extra, not linearly independent, right? For the basis, you have to have all the vectors to be linearly independent, and this is something I think I'm just appending 0 or 2 or something like that. This is anyway 4-dimensional space, so this is even not the option. Okay, understood? Yes. So one of the student is saying yes. So column space change in the row operation. That is a nice observation, right? Column space change. So he's saying no. Basically, you can put the comma here. No column space change in the row operations. Yes, that is correct. Okay. Now let's just move to the next question. So in this question, it was related to basically rank of AB. AB means augmented matrix, and they are saying they are having two cases. Either it is 3 or 4, right? Rank of A is given as 3. The number of solutions to the system depend on the augmented matrix AB. So they are saying there is a matrix A which is having 4 rows and 5 columns. 1, 2, 3, 4, 5, right? This is 4 into 5. Now rank of A equal to 3. Rank of A equal to 3, right? So it is given in the question. Now they are saying that suppose augmented matrix has the 3 rank. Augmented matrix means you are appending one column. So basically here you have out of 5 you have 3 linearly independent already, but this is not contributing anything. If the rank still is 3, it means it is not contributing anything. Okay, contributing means it is not even different. I mean, this is not different from what I already have. Then in this case, will you be having the solution? Tell me. It is not different from what I already have. In this case, will you be having solution? And if you are having the solution, then will you be having infinitely many solutions or just a solution? Since these are, I mean, all the vectors are linearly dependent. So if there is a solution, then it will be infinitely many. There cannot be unique solution case. Okay. If there is a solution, either this is infinitely many or there is no solution here. Okay. So see, it cannot be unique solution. Okay, whenever in either case or case B, whenever there is a unique solution option, in this case there is a unique solution, so that is why these two are anyway incorrect. You cannot have unique solution in this case because you have five linearly dependent columns basically, right? And all are not linearly independent. So out of five you just have three. So there will be no unique solution. Okay, there is either no solution or infinitely many. So if it is actually not contributing extra, this is not something different. This is already what you already have, right? I mean, this appending this is saying, okay, rank is not getting changed. It means you can produce this also. So that is why there is a solution here. Okay, and in this case you are having something as extra, right? I mean, you just increased your rank. If you are increasing your rank, it means there is no solution here. Okay, because this is something different in that case. Are you getting my point? Okay, are you getting my point? So basically, if you are having, let's suppose, okay, some A, and if you're augmenting, okay, B, if you're augmenting B, right? In this case, what will happen? Tell me. So in this case, if you're doing so, then in this case, what will happen? Here, you will notice that this rank, let's suppose this rank is 3, okay, rank of A is 3. Then if you are adding this and augmented rank got increased, it means this is something else. I mean, this is alien. Okay, for that space it is alien because your rank got increased. You have something extra linearly independent. If your rank is increasing, there is no solution. Okay, if your rank is increasing, then there is no solution. You just got some alien. Okay, there is no solution. If your rank is not increasing, then there is a solution. Now the solution are unique or infinity depend on whether you have linearly dependent or independent columns. So combinedly 5 columns are not linearly independent, so that is why there will be infinitely many solutions, right? Okay, now let's just see this. Okay, is there any doubt, by the way, in the previous question? Is there any doubt? Okay, now they're asking it this to be differentiate. Okay, they are asking this to differentiate. So if you differentiate the first term, okay, see, in general the first term differentiation is actually q transpose plus q, okay, into x 1 by 2. Okay, I mean the 1 by 2 will be as it is. The first term differentiation actually q transpose plus q. But since this q is a symmetric matrix, that is why generally actually for these kind of quadratic equations, if this is symmetric, then the differentiation is just qx. Okay, or the sorry, q transpose x. So it could be q transpose x, or I mean qx or q transpose x actually doesn't matter because it is symmetric. You can write anything. So since it is 1 by 2 and this is q and q transpose are same, this is 2q transpose or 2q. Okay, and 2 and 2 will get cancelled out. So that is why it is just you can write qx also, doesn't matter. Okay? Because q is symmetric. Minus, then there is a r transpose x, right? So minus r transpose. Okay, or maybe if you are not writing with respect to transpose, because I mean these whether you write r transpose or r, this will get clear from the options. Okay, so minus r, because this is just linear in x. So from here, if you just differentiate to 0, from here you will be getting x equal to r, I mean qx equal to r, then x will be q inverse r, right? So that is why B is correct answer here. Thank you so much. So there is one of the student who is saying that people who has watched Go classes lectures. So he's, I think, talking about the previous question. Okay, he's talking about this question. So he's saying that if you have watched Go classes lectures, then you can't do mistake in these kind of questions. Yeah, that is actually true. I mean, if you have revised also. So sometimes it happens that if you have not revised, then maybe you can mistake. But yeah, if you have also revised, then this kind of mistakes won't happen. Okay, now let's just solve this question. This question was nice question, I would say. Okay, this question was related to entropy. I think, yeah, this was related to entropy. So they are saying it is easy question. That is why I have put it as 1 mark question only. They are saying that big equal to y. So big is y here, right? So in that case, and big is n here. So in that case, if you just separate out this data set, okay, so where big is y, I mean we are only interested in this data set where big is y. Okay, let's not worry about the data set where big is n or something like this. In that case, you will say that, okay, there are two rows, okay, with respect to output, there is one s and one h. There is two rows, which one is having s, one is having s and h, right? So if you observe this, this is basically half half, right? 50% s and 50% h. In case of half half, this is highly you can say randomness, okay? High entropy will be there. We have already discussed these things. So if this is half half, then there will be high entropy, high kind of randomness is there. Okay, so the entropy will be maximum here. Entropy is max, and maximum entropy is actually 1. So 1 is correct answer. Is this understood to everyone? Let me know. 1 is the correct answer. I mean, we will be calculating also. We can definitely calculate, but I'm just telling you, okay, from the perspective of intuition, that what to do, right? So how to calculate is very easy. Okay, minus p into log p, p1 log p1 minus p2 log p2. Okay, so p1 and p2 both are 1 by 2 actually. So minus 1 by 2 log 1 by 2, and since both terms are same, you can just multiply by 2. So it is 2 power minus 1 log base 2, 2 power minus 1, and this 2 will get cancel out. So minus 1 will be plus 1. So ultimately it will be, sorry, log 2 will be 1 only. Okay, ultimately it will be log 2, which is finally 1. So we can calculate using formula. This is the formula of entropy. But also you do not need to calculate if they are 50-50%. This is the highest entropy you can ever assume or ever expect. Understood? Let me know if that is fine. And then we will be moving to the next question. Next question was actually interesting one. It was related to SVM. SVM, leave one out cross validation errors. Okay. So what they are saying is that in this question, what is the leave one out error? See, these are one class, right? Okay, maybe I can just take in the white background, because in the exam it was white background. So let me just copy the white background image. Yeah. So they're asking leave one out error, right? So what, by the way, what was your answer for this question? 1 by 7, 2 by 7, what was your answer? See, if you just leave any of the support vector, okay, if you leave this and then you try to train, then the boundary won't change, right? The main thing here in the leave one out, if the boundary is changing. So here boundary won't change, but if you leave this, then definitely boundary will change, right? And then it will be misclassified. So it is a leave one out error. Here only, leave one out cross validation, or what, leave one out cross validation error, right? Here only. So it will be only for 1 point out of 7 points. There are 7 total points, but only for 1 point there will be the leave one out error, right? So is this concept clear, by the way? Because I have asked I think enough questions from this concept. In the AIMTs, I have asked enough questions from this concept. Is this concept clear to everyone? What is the leave one out cross validation? How to do it? Because they might ask this. Okay. I mean, GATE 2025, they might ask these kind of easy questions. I mean, it is easy once you know the concept, but if you don't know the concept, it might be tough only. Okay. So one of the student is saying that how to decide when to use Gini index and when to use entropy. You cannot decide. It will be given in the question. It will be given in the question. Okay. Whether to have entropy or Gini index. If you are asking for the practical purpose, that for my data set how to decide, then you can try both of this. Okay. Both are almost same. I think in the class also we have tried to show you using the figure, okay, or using the diagram also. Both are almost same. Gini index and entropy both are almost same. Now let's just solve this question. This question has been quite interesting one. I think some of the people have really liked this question. Okay. Have you liked this question? This question was nice. Just one more question. Have you liked this question? Let me know. So what this question is saying, they are saying in the usual formulation of soft SVM, each training sample has a slack, right? and we impose a regularization like this. Consider an alternative formulation. So they are suggesting some alternative formulation, okay, where we impose the additional constraint, something like this, for all ij. So they are saying that we are having slacks as same, okay, this is additional constraint. So basically you are having less flexibility here because you are putting more constraint, okay. So you can say it is less flexible, in the sense that if originally, obviously originally it is producing some optimal solution, okay, it will produce the optimal solution based on the formulation that you are having. Original, this is the original optimal solution. Now you are doing some modification after introducing some, you know, additional constraint, and now what they are asking, how does the minimum objective value, this obtained by the new method, compare to the obtained by the original software SVM? Okay, so how does this new how does this particular, you know, what they're saying, how does this objective value will change compared to the previous and compared to the new? So they are comparing in the both, okay, previous and new. Since your original, whatever it is giving, for original it is optimal, right? I mean, it might not be overall optimal, in the sense that might, if you change value of c, then you might see, okay, I mean, the optimal definition is here in the sense that it might not be, you know, optimal for all the test set, okay. But what I'm saying, for given c it is optimal, okay, for given things it is optimal. Now if you put additional constraints here, then obviously it will be less optimal. So new minimum will be greater than equal to the original minimum, because we are adding some constraint. Now it is less flexible, okay. So it was one of the questions that people have liked it. Let me know if that is okay to everyone. Okay, now let's just see this. Which of the following quantities affect bias variance trade-off? So it means they're affecting the regularization. I mean, model complexity and all. Bias variance trade-off means model complexity. Okay. So what they're saying, lambda, if lambda is regularization constant, does this affect model complexity? What do you think? It was also actually a nice question. It was also really a nice question. Does lambda affect model complexity? What do you think? Yes, right. Definitely, lambda is something which is basically having main role in the regularization. Okay, so it will definitely affect the model complexity. Do learning rate affect the model complexity? See, learning rate can affect the model convergence. Okay, can affect model convergence, whether it will converge slow or it will not converge at all. Okay, learning rate can affect this, but it cannot in general affect model complexity. What about select parameter? Yes, if you make it too high, then it will be, you know, same as the hard margin. If you make it low, then it will be soft margin, like this. So yes, it affect. So basically it is whether it is soft margin or hard margin, it will affect, right, the model complexity, or at least it will affect the bias variance, in the sense that if you change c, then bias and variance will get changed. What about this? Yes, if you are having, you know, higher degree, then it will be more complex, then variance will be increased, right? So d high, then complex model, then variance is increased. Okay. Yes, it was actually also a nice question. Now let's just see this. In this question, they are asking that which one is strictly dominating the other one. So in this question, actually, some people have argued about the thickness of the line, which I agree. I mean, to some extent, I agree. So basically, in this question, they are saying that which is basically strictly dominating. Okay, which of the following relation is true? So is C strictly dominating D? Tell me, is C strictly dominating D? So see here, see if you observe that C is this and D is this. So yes, C is strictly dominating D. D dominates C? No, obviously. A dominates B? No, because A is not strictly dominating B, right? B strictly dominates C? B and C. So some people have argued here that here it is, I mean, what is happening, it is not very much clear. So actually, from the previous trend or from this line, it is clear it is always below. But some people have zoomed it out and they are talking about the, too much of thickness. So because of the thickness, it is not very much clear here that what is happening between B and C. Okay, is this overtaking, or it is just because the thickness is more, that is why it is seeming like overtaking, right? So actually, it is. I agree. I mean, here we can definitely argue, but I haven't thought in that perspective while I was designing the question. So here I mark at D, but in gate, if that is kind of situation arise, then we can zoom it out, and then we can probably, okay. I mean, I'm not sure if our challenge will get accepted or not, but we can probably talk about it. Okay, since this is basically not very much clear whether it is strictly dominating or not. So yeah, so we can definitely talk about it in gate. Okay, I mean, we can challenge this question if that is required. It is given in the question. Okay, the strictly dominating definition is given in the question. They are saying that it strictly dominates the classifier h if g is true positive rate is always greater than h is true positive rate, which means on the by axis it is greater. Okay, on the by it is always higher. This is true positive rate. So the strictly dominating condition is given in the question. You just have to read this question. Understood? Okay, let me know if there is any doubt here. Great. Now let's move to the next question. So this question was related to K-means algorithm, which is one of the unsupervised algorithm. Here in this algorithm, they are saying that what will happen upon convergence. Okay, so two centers will be at. So they are saying that A, B, and C. These are the 3 points. So let me just make these 3 points. Probably it will be clear after drawing. So A is at 0, 2, which means x is 0, y is 2. Let's suppose 0 is 2 is here. This is A. V is at 0, 1. Let's suppose 0, 1 is here. Sorry, x is 0, y is 1, right? C is at 1, 0. Now they're running K-means algorithm. So what was your answer for this question? Okay, what was your answer for this question? So answer here is B, right? So what they are saying that if you apply K-means, that is initialized with the center A and B. So here one of the center, this is C1, okay, and this is C2. Then upon convergence, what will the two centers? So see here that this is definitely closer to this, right? So you will say that okay, this will, I mean, for C2 you will say that this will be one cluster, and since this is A is definitely closer to C1, so this is one cluster after one iteration, right? Now this center will get shifted into between midpoint of A and B, right? B and C. Now if you observe again, now if you apply one more iteration, then obviously this is closer to this, or this is closer to this. So since this distance is 1, this distance is 1, right? What is this distance? So you can say this is 1 and 1, this is 2, so it is root 2. Root 2 is this distance, root 2 divided by 2. So basically 1 by root 2, right? I mean, this is less than 1. I mean, this is 1 and this is 1 by root 2, which is less than 1. And this is also 1 by root 2. Sorry, it will be root 2 by 2. I think it will be 1 by root 2 only, right? Yes, it will be 1 by root 2. Root 2. Yes, it will be 1 by root 2 only. So it is less than 1 basically, right? So it will, I mean, this center will not get shifted. So basically this will be only one cluster, this will be again cluster. So A and midpoint of B and C. Okay. Understood? Let me know if that is okay to everyone. Okay. Now let's just see this. Consider the following binary search tree. Suppose we remove the root. Okay, suppose you are removing this root and replacing with the some left subtree. Then to whom you will be replacing? You just have to have in order here. So if you have in order here, then it will be like this. So what is just lesser than 14? What is just lesser than 14 in the in order? You can easily check the in order and tell me what is just lesser than 14. 5, right? So 5 is the correct answer, right? We will be replacing with the 5. Okay. Cool. Now let's just see this question. This question is interesting one only. Okay. This is an interesting question. So in this question, they're asking that suppose we have these three clustering methods, k-means, k-measured, and hierarchical. Suppose we have these three clustering methods. In those cases, see, k-means and k-measured is almost same. In k-measured, the cluster centers are the data points. Okay, let me write it. Cluster centers are just data points. Okay, that's the only difference. You might already know this. And then there is third one, which is hierarchical clustering. Okay, now what they are saying that with the access to NYN matrix pairwise distance, but no access to the data itself, we can use which of the following clustering techniques. Okay, so they are saying that you have pairwise distances, so which means you know what is the distance between A and B. Okay, or you know what is the distance between A and C. For example, this distance is, let's suppose, 2. You know the distance, but you don't know the coordinates of A, you don't know the coordinates of C. You just know this pairwise distance matrix. Let's suppose this is pairwise distance matrix. You just know this. You don't know anything else. Okay. Now in this case, can you apply k-means? See, for the k-means, you have to know. Okay. See, you have to cluster. You have to basically calculate the center of the clusters by taking the average of all the points, right? So basically, here we take average of all the points in the cluster. Take average of all points in cluster to find out to find out the center, right? Cluster center basically. So here we have to know what is the coordinates of the points. Okay, so that is why A is not the correct answer. Basically, they are saying that in which of this algorithm, if you don't know the cluster centers, still it can work. I mean, if you don't know the coordinates, okay, you just have the pairwise matrices, then still that can work. So k-means cannot work for sure. What about k-modites? See, for calculating whether this point is near to me or this point is near to that, you just have to know the distances, right? So distances are already there. Okay, here also distances we have. We can basically say that okay, this is one cluster. I mean, we can at least you can say we can run only one iteration. We can just say okay, this is one cluster, this is another cluster. But now when we have to calculate or when we have to find out the cluster centers, in that case, k-means will create a problem if we don't have the coordinates. But if we don't have the coordinates here, k-modulus says that I don't care. I just have to know the distances, and ultimately, I will say that okay, now my new cluster point will not be a random point which I will be calculating using the average. I will be just calculating based on the distance again. Now see the cluster center is again based on the distance. Not we will not be taking the average here. Okay, in the k-modulus we don't need the clusters, we don't need the coordinate of the points, individual points. So that is why this is true. Again, this is also distance based, right? I mean, you just need the distances here also in the hierarchical also. We just need distances. Okay, so that is why this will also work. In the lectures we have solved questions using the pairwise distance matrix for the hierarchical case. Do you remember? For the hierarchical, we have solved these kind of questions. So B and C are the answers here. This was the nice question. Okay. Now let's move to the next question. What they are saying? Consider the following training set. Okay, this is negative, positive. Consider the following training set. A test point is given 2, 3. The perceptron is used with learning weight in this, where W0. So they are saying that, okay, these are the negative points and these are the positive points. And there is a test point which is given. Now, you have some initial weights for the perceptron. Simulate one iteration of the perceptron algorithm by processing the training points in the given order. Okay, I mean, you just have to take this order and you have to simulate one iteration. And then what they're saying, using the weights after one iteration, determine the predicted class of this 2, 3. Okay, so this was really a nice question which is testing you if you know perceptron mathematics or if you can apply the perceptron on the example. Okay, so this question was testing that kind of concept. If you can apply perceptron on given example, on given this toy data set. So, so let me know if you can do it. So what is the perceptron update formula? Can you tell me how the weights will be updated? Just let me know. See, see, the perceptron update formula is this. If there is a mistake, okay, or misclassification using the current weights, then perceptron only update, otherwise it won't update. Okay, that is for sure. Then how it will it update? W equal to the old W old you can say, plus how will it update? Alpha into, I mean, whatever is your learning rate, this alpha into y into x. Okay, this is your learning rate. Understood? If there is a mistake, then only it will update. Otherwise, it will not update. Now let's just see. See, these are the weights which are given to us. Now, using these weights, okay, can you tell me whether the first example, okay, so this is the bias, okay, first term is a bias, which is written here. Can you tell me whether the first example 1, 1 is classified correctly or misclassified? So just tell me what is W transpose X plus B. Okay, B means W0. Tell me. W transpose X will be minus 15 plus 5, okay, plus B is 3. This is W transpose X because this is just 1, 1, which is minus 10 plus 3, which is minus 7. Is it greater than 0 or less than 0? This is definitely less than 0, right? So basically you can say predicted class is minus 1 and actual class is also minus 1. So this is not a mistake. So you will not run your first iteration on this. Is this correct? Or I mean, is this understood to everyone? Okay. So no, it is by into not W transpose X, it is by into X only. Okay. This is the update rule. Now for this 1 and 1, there will not be any update. Okay. For this 1 on 1, there will not be any update. What about this 3, 1? Is this misclassified? That's the only thing you have to check. So 3, 1, right? So you're starting with your starting weights, initial weights are sorry, here W naught is the bias. Okay, so you have to basically minus 15, okay, and then 5 and 3. You have to do 5 plus 3 minus 10, 8 minus 15, which is minus 7. Okay, so because W naught is the bias. So basically you can say W1 is 5 and W2 is 3, okay, and bias is basically minus 15. So let's just take each example one by one. So tell me, is this 1 comma 1? Okay, the actual you can say it is negative. Actual label is negative. Let me copy all of these. Okay, so maybe I can write it here. Actual label, as you know, it is negative, right? Now, what is W transpose X plus B? You will get to know this like this: 5 plus 3, because W transpose X will be just 5 plus 3 minus 15, which is minus 7 only. It is less than 0. So predicted, let me write the predicted here. Okay, actually you already know it is minus 1. Let me write the prediction also here. So predicted level is minus 1, which is matching with the actual level. So there is no update happening because of this particular point. Let's just take the next point, which is 3 comma 1. Okay, now what is W transpose X plus B for 3 comma 1? it will be 5 into 3 15 plus 3. So it will be 15 plus 3 minus 15, which is 3, and it is actually greater than 0. So predicted is plus 1. Is this understood to everyone or not? So predicted will be plus 1 here. So now you will be updating. So now update W, because there is a misclassification, or there is you can say, using the weights we have got plus and actual is negative. So update W. Okay. So update W. How we need to update? As we know the formula, right? W old plus alpha into W old. So it will be W old. Basically these are the weights. So you can update bias and weights separately or in just one equation. Okay. This is your choice. I'm updating separately. Okay. So W old, this is just W. I'm not taking bias. I will update it separately. And alpha is given to you, I think, which is 0.5. Okay. So alpha is 0.5 into y. What is the actual y? Okay. It is -1 into x. What is x? X is actually 3,1. Is this understood to everyone or not? Let me know. So if we update it, it will be minus 15.5. Sorry, you are updating bias separately, right? So you can update just weights. Okay, if you want, you can update the bias in this also. You just have to append 1. Here in the input you just have to append 1, and you can write the bias 15 if you want. Okay, let me just do it in just once. In the input you just have to append 1, as we know. Okay, for the bias accommodation, if you want to accommodate bias in the weights, then in the input, corresponding input will be 1 for the bias. Okay. Okay, so finally it will be minus 15.5 basically, and then 3.5 and 2.5. Okay, so most probably this calculation is correct. So it will be minus 15.5. So you can check minus 15, and if you subtract 0.5, so this is minus 15. If you subtract 0.5, it will be minus 15.5, right? Okay, so this is the bias. This is a new bias. This is the new bias. New bias term. These are the weights. Now you have to keep on doing in the same way. Okay, you have to keep on doing in the same way. So you have to keep on updating. Now if you notice, okay, just after this update, then there are other points also. 1 4 is next point, 2 4 3 3 and 5 1. Okay, so let's just move to the next slide and let's just update. Okay, let's just update on the remaining points. So now my new weights are this. Let me write new weights. Okay, now my new weights will be 3.5, 2.5, minus 15.5. Okay, these are my new weights. Is this understood to everyone? Now what we need to do, we have to basically calculate our W, right? Sorry, we have to calculate W only if there is a misclassification. So now let's just take the next point. What is the next point here? 3,1, right? 3,1 is next point. So if you take 3,1, see, these 2 points are done. Sorry, 1,4. So 3,1 and 1,4 are done. You just have to take the third point and the remaining points also. So let's just do for 1,4. Will there be any update? You have to check it, right? So what is your W transpose X plus B? Okay, for this particular point, what is your W transpose X plus B? If you do this, these are your W's, right? And 1,4. So 3.5, it will be 3.5 plus 2.5 into 4 minus 15.5. Okay, this will be something like this. Is this understood to everyone? Which will be minus 2. Since it is also negative, and our prediction, our actual class is also negative. So this is basically prediction. Prediction is negative, right? Prediction is -1. Actual is also -1. So there is no update required for 1,4. There is no update required. Now let's just move to the next, which is 2,4. Okay, our weights will remain same. There is no update required for 1,4. Now what is W transpose X for 2,4? This will be W transpose X plus B, right? This will be 3.5 into 2, which is 7, plus 2.5 into 4, which is 10, minus 15.5. It will be something positive, right? It will be 1.5 or something, which is greater than 0. And again, our prediction coming out to positive, and our class is also positive. So there is no update required for this also. Now let's just check the next one. Is there any update required for the next one? If you notice at 3 comma 3 and at 5 comma 1, okay, if you just check for both of this, you will realize that for both of this also we don't need any update. Okay, for 5 comma 1 and for this we don't need any update, which means prediction is actually coming out to be positive. Okay, if you just do the simple calculation, only one update was required. Now using these weights we have to classify our given sample point. Okay, sample point is 2 comma 3. So just tell me what is W transpose X for this test point plus B. So it will be 2 into 3.5, which is 7, plus 3 into 2.5, which is 7.5, minus 15.5. Okay, which is something negative. I mean minus 0.5, which is negative. That is why minus 1 is correct answer here. Okay, that is how you need to solve this question. This was little lengthy, but it was a nice question. Okay, so it was little lengthy, but it was a nice question. How to solve it? You have to find out W's and just check if there is any update. Then if there is any misclassification, then only you will be updating. Otherwise you have to find out W transpose X plus B for each of the point. Okay, keep on doing it. If there is any misclassification, actually only misclassification happened at this 1 comma 1. So that is why we have to update. Sorry, I think 3 comma 1 or 1 comma 1. At 3 comma 1 there was misclassification at 3 comma 1, right? That is why we have updated at 3 comma 1. Only one update, and after that everything was fine. Okay, so this was, I will consider this as a nice question. Here you know how to apply this W transpose X plus B formula. This was tested. Understood? Let me know if there is any doubt in this question. And now we will be moving to the different question, right? Okay. So let's just see this question, which is question number 38. What this question is saying: a classifier maps a feature vector X in a vector space X. So they are saying two classifiers are same if they are producing same output for the given input, right? Now that's what they are saying. Now they are saying you just consider two cases. In the case first or case A, there is a classifier C1 that uses L1 distance, but C2 uses L2 distance. Okay, so C1 and C2. In first case, you can say case A, this is using L1 distance and this is using L2 distance. Okay, now there is a case B. This is using L2 distance. This is using square of L2 distance, square of L2. Okay, actually see, case B is very easy in the sense that if something is having fx for the distance metric, okay, or some d, okay, some distance metric is if some classifier using some distance metric, and if you're using monotonically increasing function, okay, or d square log d or whatever, right? If you're increasing, if you're using monotonically increasing function here, if some is greater or lesser in this space, so what I mean to say, let's suppose x1 is less than x2. Okay, then after applying fx, which is an increasing function only, okay, then this is true, right? After applying fx, if this is monotonically increasing function, after applying fx also, this is true, right? So basically since distances are always positive, okay, I'm not worrying about the negative graph of x square. Okay, let's just worry about the positive part of x square, because distances are always positive. So you can say it is increasing function. X square is increasing function for the at least positive part, right? Because distances are always positive. So that is why if something is here, so whatever relationship you are holding here, you will relate here also, right? So if you are classifying some point using 1 and n, right? So if you're classifying some point positive, negative, whatever here, you will do the same thing here because the distances are not changing. Okay, but let's just see if you're using L1 or L2, then in one of the classifier, if x1 is greater than x2, but it might I mean x1 is near to, you can say x1 is near to x2. then x3 in one of the distance metric, it might be possible that in another distance metric it is not true. Let's just check. Okay, so let's just do it step by step. What I mean to say, let's suppose that one of the classifier, okay, is using L1 and another is using L2. Let's suppose if using L1 and L2 changes our answer, or it doesn't change our answer. So for that, what we can do, we can provide you some counter example here. Okay, suppose there are 2 points. Let's suppose these are the 2 points. One is 3,3, another one is 5,0. Okay, suppose these are the 2 points here. And then let's suppose a test point which is very near. I mean, we have to take 3 points, then only we can have this. So these are the 2 points, and then for the test we are taking the third point, which is EG1, which is origin. Okay, 0,0. Now here this is 6 away, right? This is 6 away and this is 5 away, which is very obvious. I mean, this is 3 plus 3 6. This is 5 plus 0 5 away, right? In L1, what about this test point with respect to L2? This is 3,3. This is 5,0. Okay, how much away this is? This is 3 square plus 3 square root, which is 9 plus 9, which is square root of 18, and this is square root of 25. Then obviously square root of 18 is lesser, right? Square root of 18 is lesser. Actually this 5 number is dominating too much because of the square. That is the problem here. Okay, this 5 number has got dominated too much. It is just a linear summation, which is 6 and 5. Okay, this is just a linear summation. Here this is 9 plus 9, which is 18, right? And here, because of this 5, it got shoot up too much. That is why you are saying that this distance is larger in this space. In L2 metric, this distance is actually larger. Okay, if you compare 0, 0 from how much far it is square root of 25, larger compared to 3,3, which is just square root of 18. I mean, you don't worry about the square root, because this is anyway increasing function, but yeah, if you take the square root, that's fine. Okay, this is like 5 and this is like almost 4. Okay, I mean, this is actually smaller, right? But in this space, so you will say here it is large, so final answer will be based on this 3 3. But in this L1 here it is small, because this is just a absolute summation. Here this distance is small, here this distance is small. Interesting, isn't it? So that is the reason I have given this question in the exam. Okay, so the conclusion here is that whatever you are doing for the distance distance based algorithms, okay, whatever you are doing in L1 need not to be 100% mapping to L2 only. Okay, so L1 might using L1 you might get different answer in 1nn, 2nn. I mean, any distance based metric algorithms. Okay, 3nn doesn't matter if it is just 1nn or not. Okay, any distance based metric algorithms. Okay, whatever they are giving answer using L1, they might differ from using L2. Okay, whatever they are doing using L1, the answers might differ in those kind of algorithms using L2. Understood? Okay. Now again, this was related to hard margin, and it was a hard question also. Okay, this was a hard question. I mean, hard in the sense you have to apply all the equations of SVM. Okay, so they are saying that you have to train by hand. Okay, in the sense that these are the two examples, and you have to train by hand, and then using that you have to find out all of these values, alpha and b. Okay, so what are those training points? Let me just copy that. Okay, so you have to train hard margin SVM by hand. Let's just do it. So by the way, how many of you were able to solve this question in the exam? This was honestly not a tough question. Okay, you might have able to solve it, but I'm just asking you how many of you were able to solve it. I mean, it was a tough if it is very first question, in the sense that we have not asked this kind of question earlier, so that is why I'm saying it is hard question. Otherwise, if we could have asked these kind of questions very frequently, then it might not be that hard. Then you know that how to solve these kind of questions, right? See, for the SVM, what are the formulas? Okay, SVM final formulas. You know that W is nothing but summation of all weighted summation of all the support vectors. Okay, these things actually we have derived. Okay, we have already derived. Here there are 2 points, so that is fine. Now there is one condition. Okay, we have already derived that alpha I by I is actually 0. Okay, that condition I think we have got if we differentiate the original objective function with respect to the bias term. Okay, I think we have got this condition from that only. Okay, and we know for the support vectors, right? So w x plus b equal to 1 or minus 1 depends on their support vector is positive or negative, right? 1 or wx plus b is minus 1 for the support vectors basically. Okay, so these are the few formulas that we have in SVM. Now let's just apply these formulas on this particular, you can say, data set, toy data set, right? By the way, this question I've taken from MIT, and the only reason I've taken this question to make sure that you know about SVM formulas. And in case if they ask anything about it, you should be able to answer, right? That is the only reason. Okay. So what is the W here? As you know that x and y are given to me, right? It is just a one dimensional data, so I'm very relieved about it. Okay, because in this case you don't have 2 dimensional or 3 dimensional, so it is just one dimensional data. So it is alpha 1 by 1 x1 plus alpha 2 by 2 x2, right? Okay. Now if you apply this by 1, which is plus 1, and x1 is 0, so it will be ultimately 0 plus alpha 2, right? Alpha 2 by 2 is minus 1 and x2 is 4. So basically you will say minus 4 alpha 2. So this is W. Okay, so let me write W here. W is coming out to minus 4 alpha 2. Is this fine to everyone? Is this fine to everyone? Let me know. Now as I just told you, that we know that this kind of optimal at the optimality, this kind of equation should also hold. So basically we can use this to relate alpha 1 and alpha 2, and that's very easy, right? So alpha 1 will be equal to alpha 2. If you see this is alpha 1 minus alpha 2 should be equal to 0, because one of them is plus 1 and another one is minus 1. So alpha 1 should be equal to alpha 2, right? From this we can infer that alpha 1 is equal to alpha 2. Is this also fine to you guys? Okay, using this. Okay, now only thing that remains is basically is this formula, which is related to support vectors. If this is support vector, then this will happen. Okay, so now can you proceed further, or can you give me a hint that how to do it? See, by the way, this is hard margin. In hard margin, if you just have 2 points, right, then one is positive, one is negative, then both are support vectors only. You just have 2 points in hard margin. This is positive class, this is negative class. Obviously this is a support vector, this is a support vector. Both are definitely support vectors. This is one of the key point. Can you say this? Definitely support vectors. Both are the support vectors only. Why? Because one is positive, one is negative, and there are only 2 points. So this has to be support vector, this has to be support vector. So you can say both are support vectors only. So if you apply this on the positive, okay, for the positive, for the first example, you can say bias is just 1, because x is 0, so bias is just 1. Okay. So you can say wx plus b equal to 1 plus 1, right? For the example number 1. if you apply this, it will be w into 0 plus b equal to 1. So it will be b equal to 1, right? Bias is 1. Now if you apply this on the next point, then what you will be getting? It is basically w into 4, and b I already got 1 equal to minus 1. So I think you have got w also, right? You have got, from here you have got w. And what is that? 4w equal to 2. So w equal to 1 by 2. Is this okay to everyone or not? Actually, w they have not asked in the question, but that is fine. Okay. Let me know. Sorry, this is minus 1 by 2. I'm sorry about it. This is minus 1 by 2, right? Now they're asking about the alphas. So if you put this as minus 1 by 2, you will get to know alpha is 1 by 8. Right? Alpha 2 is 1 by 8. Alpha 1, alpha 2 is 1 by 8. And bias B is 1. So these both are 1 by 8 and bias is 1. Is this fine to everyone? See, let me just tell you that I will be asking the same question, okay, with the different data, because I want you to practice this kind of thing, okay. With the different data, I will be asking the same question in next test also, because I want you to solve these kind of questions. Because in gate they may ask some tricky question from SVM, okay, and then you should be able to solve it, okay, with different data. Or maybe I will be putting some extra tricks or something like that. I mean, extra something to trouble you. But yeah, almost same question I will be putting in the next AIMT or in the next text. Okay, so I will be doing it. Okay, now let's just solve this question. Given the training set below, this, and then they're asking this question related to the naive Bayes. You know what is the naive assumption? That given the class, if these are the two features, given the class, the features are actually independent, right? So x1 given c into x2 given c. I'm just telling you, this is the assumption that we have in the naive Bayes. Okay. So in this question, they're asking you to calculate some probability. This probability is something like this. Okay. Let's just do it. By the way, how many of you were able to solve this question? See, you just have to apply the Bayes formula first, and then you can solve this question easily, right? So see, they're asking about this particular probability. Right? And then using the Bayes formula, you know that this particular probability, whatever they're asking, is basically something like this, right? They're asking about this probability, right? Which will be probability of this, I mean the joint probability here, and then using the naive assumption, I have written this, okay, using the naive assumption, in the sense that it will be like this. See, probability of u equal to 0, comma x equal to 0, comma y equal to 1, comma z equal to 0, divided by this particular probability, right? I mean, numerator I'm not writing. And then you can take probability of u equal to 0 like this, into given u equal to 0, and given u equal to 0, you can separate it out into three terms, okay? Into, you can say it is something like this. Given u equal to 0, and then this term you can separate into three different terms using the naive assumption. This is the important point here, okay? These are the three terms, okay? In these three terms, you can separate it out. Is this fine to everyone what I'm trying to say? Because it should be understood. It should be understood. Great. Let me know. By the way, if you have any doubt here, then it should be clear, because otherwise you will not be able to understand the whole solution. Okay, it should be clear that what I'm trying to say. So what I'm saying here is that ultimately you will be getting this formula. And now let's just see what is given here as a table, right? Okay. So they have given this table. These are the zeros, these are the ones. X equal to 0, y equal to 1, z equal to 0. Okay. So what is the probability of y u equal to 0? Can you tell me what is the probability of u equal to 0? This is 3 times. 1, 2, 3, 4. This is 4 times. So this is 3 by 7, right? Is this fine to everyone? Let me know. What is this? X equal to 0, given u equal to 0. So what you can do, you can find out given u equal to 0. So this is, I think everything is equally likely here. So given u equal to 0, what is x equal to 0? So this is 2 times out of 3 times, right? So it is 2 by 3. Is this fine to everyone? Okay. And then you need to find out for, let me find out. You need to find out for u equal to 0, what is the probability? Y is 1. Y is 1, it is just 1 time out of 3 times, 1 by 3. For u equal to 0, what is the probability? Z is 0. Z is 0 only 1 time out of 3, right? So it is 1 by 3. So it is 3 by 7 into 2 by 3 into 2 by 3 into 1 by 3 divided by, okay, when is 0 1 0 occurring? 0 1 0. 0. Only one time, right? Only one time. Or is there anything else? 0 1. I think only one time it is occurring out of 7. So it is 1 by 7. Okay. So 7 7, let me just cancel it out for easier calculation. Then it will be, is this fine or there is something I'm missing? This is 12, 3 3 will get cancelled out. This is 4 by 9. So I think answer is 8 by 35. Answer is different. Okay. So this thing also, interestingly, this thing also has to be solved using the naive assumption only. So which means we have to basically separate it out. Okay. We actually, this is one silly mistake that many of the people have done. So you have to separate it out and then only you have to calculate it. You cannot calculate it directly 1 by 7 because here the naive assumption is not coming into the picture. So what you need to do, you basically, I think many of the students, right? Many of the students has done it. So basically, I think let me just check the comment. Yes. So Bhuvan Raj is saying that split the denominator. Yes. So actually, after the exam also, some of the people have said about it that they have done this mistake. Okay. So they are saying that this particular denominator, they were not splitting it. We have to split it, right? Because we have to incorporate the naive assumption. So what is the naive assumption? It is that you have to marginalize it, okay, using u equal to 0 and u equal to 1. So basically, what if u equal to 0 into this same thing into probability of u equal to 0, right? And then what if u equal to 1, given that u equal to 1, and then the same thing will get appear here, isn't it? So if you solve this, then the final formulation will look like this. Let me just tell you. Okay, you have to split the denominator also. Then the final formulation will look like this. And then if you solve this, then 8 by 35 is the correct answer here. So don't directly solve for the numerator. Okay, you have to split for the numerator also. Great. Yes. So so many of people, I think many of you people have done this mistake, and that is fine because that is how we are learning from the tests, right? So from the tests only we will be learning. Okay. So Bhuvan is saying split the denominator. So let me put his comment also. By the way, how was this question? Just tell me, how was this question? Have you learned something new from this question? Okay, particularly these 3 4 questions that has just come. This question, isn't it this question nice? Tell me, isn't this question nice that they are asking you to solve for the SBM? How you felt about these questions? Just let me know. Okay. Let me know your honest feedback that how you felt about these questions. Were these questions were too tricky to solve, or these questions were necessary to put in, AIMT? Tell me. But these questions too tricky to solve, or these questions you feel that okay, we should be covering these kind of concepts also, so that in case if they ask any of this in exam, you should be able to solve, right? Now let's solve this next question, okay, which is basically related to which algorithm. So they are saying, okay, regularization and all. Okay, cross validation, regularization. Is it related to regularization, cross validation, and these kind of concepts? Okay. Now let's just see this question. What they're saying: a classifier trained on 1 lakh data points. Okay, so it is a 1 lakh data points with a training accuracy of 99% gives the accuracy of this. Which of the following solutions can help us in improving the performance of the testing data? Okay, so they are saying that these are the 1 lakh data points and there is 99% accurate on the training and very less accurate comparatively, right, on the test. See, training is high accurate and for the test it is very less accurate. So it is clear case of overfitting. Okay, it is clear case of overfitting, isn't it? Now what they are saying that which of the following solutions can help us in improving the performance on the testing data? Okay, so let's just check. Basically they're asking that how to reduce overfitting. Okay, they're just asking us to reduce overfitting, isn't it? Now let's just check. We should gather more training data. Yes, actually, the more data is always better. Okay, so to reduce the variance, actually, okay, if the model is highly, because for the less data, it is easy to overfit. Okay, for less data, it is easy to overfit. See, less and high both are subjective in the sense that if you are overfitting, then more data will definitely help because model is too complex. Okay, model is too complex and it has learned all of the data. Since it is learning all of the data, what if we provide more data? It will always help to reduce overfitting. This is very interesting point. Okay, because model is simple enough to learn all of the data that were existing in your train set. So what if we have more data? That is the point, right? It is better to have more data. So we should gather more data for training. Yes. Okay. We should set regularization parameter lambda to be 0. What do you think? They are saying no regularization. So, do you think you should not be having any regulation? If you are not having any regulation, see, already it is overfitting, and if you are not having any regulation at all, then what will happen? It will weights will be even larger, right? It will even more overfit. So that's why it's not the correct option. See, see, if you are having lambda equal to 0, weights will be even more larger. Lambda is actually controlling the overfitting, right? Weights will be more larger and it will even overfitting more. So B is not the correct option. We should reduce the number of training points. No, we should actually increase it. Okay, I mean training data should be increased. We should use cross validation. Yes, we should be having some cross validation. So let's just see if we can train the hyperparameters, isn't it? Okay, maybe some hyperparameter is not good and that is why the model is overfitting. Okay, we should definitely be training the hyperparameters. Understood. So I think AD is the correct answer here. Okay. And one of the hyperparameter is lambda. Lambda itself is a hyperparameter, right? Lambda itself is a hyperparameter. So if we have the nice lambda, then probably it will help in the overfitting. Okay. Now let's just solve this question. In this question, what they're saying, let's suppose there is a hierarchical agglomerated clustering algorithm which is given to you. Now either it is complete linkage, single linkage, average linkage, or none of these. Okay, now what they are saying, if we stop when only there are two clusters remain, so basically we want to separate it out into two clusters. Okay, so which of this algorithm is basically making sure that resulting clusters are balanced? Matlab each have two samples. So basically you have to apply complete linkage, single linkage, and average linkage, and just check that okay, which is having basically two clusters as a final output. Okay, that's great. Let's just solve this question. By the way, how many of you were able to solve this question in exam? Let me know. So these are the 4 points. Let me just go to the next point, next page, and then I will be just solving it. Okay, so these are the 4 points. So by the way, the answer is A and C. Okay, I mean single linkage will not be having this, but can you tell me that how many of you were able to solve this question? Okay, Bhuvan is saying he was able to solve. Anyone else? Okay. So see, see, let's just check that what will happen in each of this, right? So one is complete linkage, single linkage, and average linkage. So these are the three. Let me do it one by one. Okay, step by step. So let's just do for complete linkage. See what will happen. Let's suppose that any of this, okay, whatever you are starting, so you will be basically first, I mean in the first iteration you will be clubbing, since the distance is same because of symmetricity, I mean it is basically on the four corners of plus, since the distance is same you will be clubbing any two. So let's just club any two. Okay, I mean you can club any two, I'm just clubbing it. Okay, this is the first iteration of any algorithm, first iteration of any of these three. Okay, is this fine to everyone? Now what will happen in the next iteration? That is the key point. See here, complete linkage will say that my distance is actually this 2. Okay, and from this it is lesser than 2. Okay, from this it is lesser than 2. 1 square plus 1 square, it is root 2. Or from this complete linkage will say it is 2. So it will say I am more biased towards, for this particular point it will say I am more biased, I mean distance between these two is just root 2 or something like this. So it will say I am more biased towards this, I mean distance between this point and this cluster, and similarly this point and this cluster is actually root 2. So complete linkage will club these two, right, in the next iteration. So basically these are the two clusters you are getting. Okay, at two clusters you have to actually stop, right? You just have to run two iterations. So complete linkage will basically do this. Why? Because this is basically distance 2. From this also it is distance 2, but this distance is just root 2. So complete linkage will say, okay, I'm fine with this. I mean, I will club these two. What about the single linkage? Or maybe what about the average linkage? See, let me do single linkage. Single linkage will say that, okay, this is root 2. This is also root 2, right? I mean, I'm equally away from these two. And what about this? This is also root 2. I'm equally away from these two clusters. And it may so happen that you are completely, I mean, since see, these are tie, and they are saying that you are tying, you are breaking tie arbitrarily. Okay, and which of the following method ensures? So single linkage will not ensure. If you are breaking tie arbitrarily, it may club these two. So single linkage will not ensure. What about the average linkage? Average linkage will say I am root 2, right, and this is 2. So basically I am 2 plus root 2 divided by 2 away. Okay, but here I am just root 2 away, right? Here I am 1 plus, or maybe in terms of root 2, if you say it is root 2 into root 2 plus 1. Okay, something like that. Actually it is greater than root 2. Okay, so it is just saying I'm just root 2 away. Okay, average linkage will say I'm just root 2 away from this, but it is something greater than root 2. So that is why average linkage will also basically, average linkage generally, okay, I think I cannot say it, but yeah, generally I think it might behave just like a complete linkage, because complete linkage, in complete linkage you have max. In average linkage, you have max, min, everything, but max will generally dominate. In the average, if max is a good number, then max will actually dominate. Anyway, like you have to run it separately, but I'm just telling you, it might behave just like a complete linkage because max might dominate in the average. Okay. So that is why A and C are the correct answers. And what about the quality of this question? Yes, this question was also, I feel, it was a good question, isn't it? Okay. For the single linkage, it is having the same distance, but since it is breaking a tie, okay, arbitrarily, so it will not ensure. It will not ensure. Okay, because you are breaking tie arbitrarily. So it will not ensure. Understood? Okay. So now let's just solve this question. In this question, they are saying, consider a recursive algorithm. Okay, where what we are doing, if that only two elements to be sorted, then you can just swap them and sort it basically. Otherwise, since it is recursive, you are sorting first n minus 1. Okay, I mean recursively sorting first n minus 1. Then you are sorting in the resulting array recursive, so last one. Then you are sorting last n minus 1. And then in the resulting array, recursively sort the first two elements of the array. Okay, then you are sorting first two elements. So basically, if this is sorting algorithm, then you are basically doing this thing. Okay, let's suppose you are passing here a 1 to n, right? Then your base case is clear if these are just two elements. Okay, if n equal to if n equal to, then you can just sort it like swap if a1 is greater than a2 or like that, right? I mean you can basically have the base case. Otherwise you will be basically first swapping first n minus 1, then you will be swapping last n minus 1, then you will be sorting first n minus 1, last n minus 1, then you will be sorting first two. Okay, so recursively sort the first two elements. Okay, so first two means fa1 2. Okay, actually interestingly this kind of algorithm actually working for sorting. Okay, so basically if you sort it, okay, if you sort, let's suppose somehow you are able to sort this, and then minimum will come here, right? Minimum, let's suppose 1 5 3 9 1 5 or 1 3 1 3 5 7 11, right? Minimum will come here and it is sorted array. Let's suppose this is sorted array, and then there is one element which could be anything. It could be, okay, let's suppose this is 2 or something. Okay, this sorted element could be 4, could be 2, or I mean this particular element could be anything. Let's suppose this is 1. Okay, and then if you sort it, then actually the only thing is that minimum might come here. Okay, or if it is, let's suppose 4. Okay, let's suppose this is 4, then if you sort it, then what will happen? This 4 will come here, right? Then 3 4 and then this, right? So it will be 3 4 5 7 11 like this. So basically it is already sorted. So what I'm trying to say, that if you sort the later part, then it might so happen that 4 will find its correct place. If that is not disturbing 3, it is fine. I mean 4 will find its correct place, and then it will since this is greater than 3, it will be anyway greater than 2, right? So it is, I mean, ultimately sorted. So see, if 4 is not disturbing 3, then if you sort this remaining n minus 1, then ultimately it will be 2 3 4 5 7 11. I mean you don't even have to sort these first two. I mean it is done, right? If basically it is 4, then this you just sorted, and then if you have 4 here, then this will be also sorted, right? I mean this 4 will find its correct place. But suppose 4 is disturbing 3, it is 1, and ultimately if it is 1, then it will disturb 3. Then in the next step we are actually sorting first two. Okay, if it is 2 1 and then 3 5 7 11, then we will be basically, if it is disturbing this, then actually we can just sort it. Okay, that's the only point. So this will, in the pseudo algorithm, it will look like this. So since it is recursive, so if it is Tn, then I'm saying it is Tn minus 1. Okay, just because it is recursive. If it is not recursive, let's suppose here let's suppose instead of this, I am saying, okay, first let me just solve this, and then I will come back to the variation. Okay, so it will be Tn minus 1, this is Tn minus 1, and this is T2. T2 is just actually constant. So it is Tn equal to 2Tn minus 1 plus 1. I mean, t2 or just constant. So if you solve this, this is exponential actually. Okay, 2 power n. Understood? So instead of what I'm trying to say, you will get to understand more. What I'm trying to say, that instead of having this is a recursive call. Suppose everything is same, only one change. I will just say that this is a heap sort. Okay, which means, or maybe sorry, you don't have heap in algorithm in the syllabus. So let's suppose this is a merge sort. Okay, suppose this is merge sort. In that case, what will happen? You will have equations like this. Tn equal to merge sort will take n minus 1, log n minus 1, or n minus 1 doesn't matter actually, n log n, right? So n log n plus Tn minus 1. Okay, but this n log n cost, actually we should be very careful. It should not be a recursive cost. It is just a one-time cost, right? It is just a one-time cost. And then, I mean, at first iteration it is n log n, then it could be n minus 1 log n or something like this. Okay, it will be recursive cost only. Cool, that's fine. So basically, if we are having something like merge sort, in that case it will be n log n. It will not be Tn minus 1. Just because it is a recursion, okay, just because it is a recursion, I am having Tn minus 1 here. You just have to understand this. It's not like that blindly I can put Tn minus 1. Okay, let's suppose this is some other sort. I have to put that time complexity. So it is Tn minus 1 because it is a recursive sort only. Okay, I mean, recursively we are using the same function. Okay, let me know if that is fine to everyone. Okay, so basically D is correct answer here. Understood? Now let's move to the next question. This was one of the most interesting question, I can say. Okay, this was one of the most interesting question that we had. Okay, what this question is saying that Tn equal to 2Tn by 2 plus order of n. Okay, this is saying order of n. It is not saying theta. It is just saying order. And that is why this question has become most interesting. So what does this order of n means? It could be 1, it could be log n, it could be n. I mean, it could be anything which is less than equal to n, right? So anything which is less than equal to n. Okay. For different cases, there could be different answers. That is the thing here. Okay, that is the thing. So let me know if that is fine. I mean, have you understood this order of n mean? Okay, what does this order of n mean? Now let's have a simple two cases. What if this is 1? I mean, this is lowest could be 1 and highest could be order of n. Oh, sorry, theta of n. So basically, what if this is just 1? Okay, you can just have 1 here, or you can have n here also, right? If it is just 1, and then if you solve this using Master's theorem, you will be getting theta n. If it is n, and then if you solve this using Master's theorem, you will be getting n log n. And Master's theorem always give answer in theta. Okay, it is saying that, okay, it is giving you the exact bound theta. It is not saying order, lower bound or upper bound. It doesn't say. Okay, I mean, if theta is possible, then obviously you can have order, you can have big O. Okay, that is there. But Master's theorem is very nice. It is more precise. It gives you theta. Theta is always better, right? I mean, if you are having theta, then it is always better. Okay. So basically it could be theta n depending on what you replace with order of n. It could be n also, so n log n also, depending on what you replace with order of n. So after solving both the cases, we can't conclude. In some cases it is theta in n, in some cases it is theta of n log n. So basically we cannot have theta as an answer. So if any option has theta bound is not even possible here. I made this question little simpler by putting the options. The theta bound is not even possible here. Because in one option, okay, it is saying theta n or theta log n. I mean, in basically one replacement you are getting theta n, in another replacement you are getting theta n log n. So you can say, if even if you are having the maximum cost, then it is theta n log n. So it is always less than equal to theta n log n. So you can say it is order of n log n should be the answer. Okay, order of n log n. Theta cannot be the answer here. Okay, order of n log n, or maybe anything greater than n log n also you can say. Okay, order of n log n, order of n square, order of n cube, or minimum is theta n, so you can say big omega of n, which means greater than, so less than equal to n. So the time complexity, sorry, greater than equal to n, time complexity is greater than equal to n, right? Because minimum is theta n. So theta bound is not possible. Big omega was possible, big omega n. Big O is also possible, but theta bound, these two bounds are possible, but theta bound is not possible. So anything greater than n log n is also the answer. Okay, so that's why D is answer. This was most interesting question. Understood? Okay. Now there are a few more questions which were also very interesting. Okay. Do you want to complete these questions in this session, or should we be taking a quick next session? Or maybe we can just complete in a single session, right? So that it will be just one video. So let's just do one thing. Can we have, let me just have some water. Can we have 5 minute break? Okay. Let's just have 5 minute break. Okay. And then we will be completing this in a single session only. Is this fine to everyone? Okay, great. So let's just meet. Let me just write it. Okay. Let's just meet at this meeting. Hi everyone. So let's just get started now. Okay. So now let's just continue with this question. This was in fact one of the interesting and at the same time easy question only, right? So what they're saying in this question, let's just see. So in this question, they are saying that you have some wedges, okay, and then this is unsorted array, okay, this is unsorted array, and this is sorted array, and they're using insertion sort. Now you might have noticed that in insertion sort basically, one of the element get inserted into its correct position at each iteration. So this is a partial sorted array after 4 iterations, right? Okay. So let's just see that what is happening. See, this is in one iteration. Basically, you will say that it. I mean, in 4 iteration, in one iteration, it might get upset. It might be taking its own position. In second iteration, it will be taking. In third iteration, it will be taking. In fourth iteration, it will be taking. Right. Okay. Now these elements will not get disturbed. Okay. So you do not know anything about these elements. Okay. You do not know anything about these elements. Okay. Now let's just check step by step. So can you say, let's just see, okay, let's just see options, that what do we have in the options. Can you say that this symbol is lesser than this symbol? Can you just compare these two symbols? No, right? You don't know anything about this symbol, right? Whenever this symbol is involved, you don't know anything about this symbol. So that's why A is not correct. Okay, A is not correct. So that is why we will say that let's just we will not do any conclusion about this particular symbol, and then we will just see other options. Okay. So let's just see the next option. Let me just talk about the next option, which is this. So what do you think about this option? See, in the sorted array, it is very much clear that this is basically lesser and this is greater. So B is anyway correct, right? B is anyway correct. Is this understood to everyone that what I'm trying to say? Because the array finally is sorted. Okay, array finally sorted. So anyway, this is greater than this symbols because this is here. So this is correct because array is arranged in the increasing order and it should be given in the question. Okay, from least to greatest. Okay, elements are arranged and no two elements are equal from least to greatest. Understood? Now, what about this? What do you think? This particular element is lesser than this particular element? Yes, because array is sorted. So yes, so that is true. Okay, that is true. So yes. What about this? This hard kind of element is greater than this. Is this hard greater? What do you think? No, right? This should be greater, right? Since it is increasing, so this should be greater. So that is why it is false. Okay, this is increasing actually. Okay, so this is anyway greater. So it is easy question only. Okay, this was easy question only. Understood? Okay. Now let's just move to the next question. I hope you understood this question. Okay. Now in the next question they are saying, consider the implementation of a stack of which is based on dynamic array allocation. So they are saying that you are having dynamic array allocation. Now this question is saying that your array size can be increased. Okay, so how you will be increasing? Suppose the array is full, then to push the next elements, we first allocate the new array of larger size. Okay, and copy all the elements of the new array into older array. So basically they are saying, if this is full, if this array is full, okay, then you will be taking a new array of larger size and copying all of this here. Okay, copying all of this here. Basically this will be copied, and then you will be basically filling. Okay, you will be filling new elements here. Okay, this will be copied basically. So we use dynamic array based algorithms. Basically, when stack is full, you increase the array size by following the sequence of k, 2k, 3k like this. Okay, I mean first from this k you will be basically increasing by k. Okay, you will be increasing by k. First it is k, then 2k, then 3k, and so on. Which means that first time we increase the size by k, and the next time by 2k, and so on. If you have an empty stack, okay, this is stack or array, whatever you say it. Okay, if you have an empty array, use the array whose initial size is k, and you perform n pushes greater than k. What is the, okay, so suppose you have basically empty array or empty stack which initially size is k, and then you want to push n elements which are greater than k. Okay, I mean you want to push more elements which are I mean let's suppose this is 10, then you want to push more elements than allocated space, let's suppose 100 elements. Okay, then they are saying what is the cost of expanding. Let the cost of expanding from k to 2k is 2k cost. Okay, similarly cost of expanding 2k to 3k is 3k cost. Okay, I mean basically the cost of larger one. If you are expanding it, then the cost of new array is the cost. Then what will the total cost? Okay, that's what they are saying. So basically initially it is k, and finally you want to reach to n elements, right? Then you will be increasing it to 2k, then you will be increasing it to 3k, and finally you will be increasing till n. Okay, that is the goal. Now how many times you will be doing? You will be doing n by k times, right? I mean plus 1 minus 1, these things are okay, but you will be doing almost n by k times. So 2k, 3k, I mean let's suppose n is equal to, let's suppose xk or something. I mean you will be basically if n is 100 and this is let's suppose 5, you will be doing it 5, 10, 20, I mean 20 times, right? So basically it will be n by k times. I mean you will be increasing by k, then k, then k, so that all of these you will be doing n by k times, right? First time the cost is 2k. Is this fine to everyone? First time the cost is 2k, and then what will the cost? Then 3k will be the cost, right? So is this little bit understood or not, what I'm trying to say? So first time the cost is 2k, then 3k is the cost, then 4k is the cost, right? Like that it will be n is the cost. So basically in terms of the k, it will be k into basically n by k, right? I mean if n is the cost, instead of n I'm writing like this in terms of k. Okay, in terms of k it will be like this. So you just have to sum all of this. And if you sum all of this, you will be getting 2 plus 3 plus 4 till n by k into k, right? So which is almost like 1 plus 2 plus, I mean sum of the natural numbers till n by k. So it is n into n plus 1 by k, right? N into n plus 1 by 2 or something like this, right? So basically, since these are n by k numbers, so let me write it like capital N. Okay, I will replace it later. N into n plus 1 by 2, something like this, right? Into k. So it is nothing but n square, capital N square, right? Capital N is nothing but n by k whole square into k. I mean, in terms of order, it is just n square. I'm not finding the exact value, but in terms of the order, it will be n square. Okay, so k square and k will get cancelled out. N square upon k will be the final answer. So basically, this is making the cost clear, right? If you're increasing from k to 2k, the cost is basically 2k. If you're increasing from 2k to 3k, then cost is 3k. This is making the cost clear. Okay. Now, let's move to the next question. So in this question, they are saying we consider log 2 base 2 of 2. Thus, log n is a natural number, n must be a power of 2. Let n be the arbitrary number. Which one of the following is true? So basically, they are asking that a binary about the binary tree with the height log n. Okay, so just tell me if the binary tree height is h or height is n or whatever, right? If height is h, okay, let's suppose this is the height, right? Then what are the minimum elements that can occur? What are the maximum elements? See, if this is height 1, then I think maximum is 2 power basically h, or maybe I can just say this is basically 3, right? The maximum number of elements, right, for the height 1, and then this is 7, right? This is 7 for the height 2. This is 7, so you can say 2 power h plus 1 minus 1, right? So maximum elements will be 2 power h plus 1 minus 1. And what are the minimum elements? It will be, I think, just as good as height, right? For height 2, these are h plus 1 or something, right? Minimum elements will be h plus 1 or something. Okay. For height 2, it will be at least 3 elements should be there. So these are the minimum and these are the maximum elements. Is this fine to you guys? Okay. Now, what they are saying, so this is 2 power h plus 1 minus 1. Okay, this is h plus. Now, what they are saying, so basically, if you are having log n, so if height is log n, then it will be log n plus 1. It will be 2 power log n plus 1 minus 1. So it is 2 into 2 power log n, right? Which is just 2 into n. So it is 2n minus 1. So basically, you can say it will be between log n, something like log n plus 1, 2, 2n minus 1. Okay, it will be something like this. Okay, by the way, root is at height 0. I think we have also considered the same thing. Okay, so basically min and max range will be something like this. Is this fine to you guys? Let me know. Okay, so you can just find out min and max range. So height of log n can have exactly n nodes. Yes, it can have exactly n nodes. It can have in between this, right? Can have exactly n nodes. That's true. Can have exactly log n nodes? No, it has to have at least log n minus 1, log n plus 1. So that's why this is false, right? This is false. Can have an n log n nodes? Can have exactly n log n nodes? No, at most it could be 2n. Okay, it cannot be log n. It can be just a multiple of 2. It cannot be multiple of log n. Okay, it cannot be n log n. Exactly n log n is not possible. Similarly, n square is not possible. I mean, n into 2 is possible only. Okay, plus 1 minus 1 is okay, but n into 2 is possible only. Multiplying by n or multiplying by n, multiplying by log n or multiplying by n is not possible. N square, n log n, these kind of things are not possible. So it's an easy question. You just have to tell min and maximum range. Actually, the similar kind of question they have asked in GATE 2024 also. Okay. Is this okay to you guys? That how to solve this question? Okay, great. Now let's move to the next question. So this was comparatively easy question from Python, right? They're asking you if list, the recursive code, I think. Yes, this is a recursive code. So they're saying that, okay, what we need to do, I think they're just reversing it, right? I mean, they're asking you to reverse basically, okay? Because they're appending the first element as a last. So you just need to reverse. So it is a reverse code, very easy. Very easy code, right? Reverse code. Okay. Now let's move to this question. In this question, they are saying what is the probability of x is less than or equal to 4? And they have given PDF, okay, probability density function. So probability of x is less than or equal to 4 will be integration of minus infinity to 4, okay, and then this fx dx. Is this okay to you guys? So this is 1 by 4. So if it is, between 1 to 5, then only it is 1 by 4. So you can say 1 to 4, there is 1 by 4. Otherwise it is 0. Okay. So you can have 1 by 4x and then which is 1 to 4. So if you put 4, then it will be 1. Minus if you put 1 by 4, it will be 1 by 4, right? So 1 minus 1 by 4, which is 3 by 4. Okay. This was also easy question only. Let me know if that is understood to you guys or not. Okay. This was also easy question only. Great. Now let's just move to the next slide. So again, it was also the easy question because in GATE also they ask 2 mark. They generally ask, okay. I mean they will be having the balance, but they might ask 2 mark question which are tough also, which are easy also. So we are keeping that kind of balance. Okay, we are keeping that kind of balance. Now they're asking for the variance. So since if you observe here, It is which kind of variable? It is a Bernoulli variable, right? It is a Bernoulli random variable. Sorry, it is a binomial. Actually, I always get confused between binomial and Bernoulli. So it is a binomial, okay? It is a binomial random variable. Now, what is the formula for the variance for binomial random variable? Can you tell me quickly? It is P into 1 minus P, right? Or here it is given as Q. So Q into 1 minus Q. Okay. This is the formula of variance. Okay. So if you put it 0.4 into 0.6, it should be 0.24. Okay. Very easy question only. Understood? Great. Now let's just check this. Let x be the exponential random variable with mean 1. The cumulative distribution function of z is given like this, right? Now what is this? It's also nice and interesting, easy question I can say. So it will be, see, it will be just z greater than 2 and z greater than 1 divided by probability of z greater than 1. Right? Okay. Now, greater than 2 and greater than 1, it is just a one condition, probability of z greater than 1, greater than 2, right? Which is nothing but, see, f is telling you less than equal to, which means f x k is actually probability of x less than equal to k, right? So here, this, if I just ask you what is the probability of z greater than 2, you can say 1 minus probability of z less than equal to 2, right? And for less than equal to 2, you just have to put 2. Okay, you just have to plug it out. There is no integration differentiation, right? So it is 1 minus e power minus 2, and 1 minus is already there, so it is e power minus 2. Similarly, this will be 1 minus probability of z less than equal to 1. Probability of z less than equal to 1 is very easy. You just put 1 here. It will be 1 minus e power minus 1. Okay, and 1 minus is already there, so it will be e power minus 1. So it will be finally e power minus 1. So that is why B is correct answer here. Okay. Okay. Is this understood to everyone? Let me know. B is this very easy question, right? I mean, the CDF cumulative distribution function is directly given, so you can easily solve this question. Now let's just see this. In this question, they are giving you joint PDF of two random variables, right? Joint PDF. They have given you the joint PDF. So what is the probability of x plus y less than or equal to 1? Here you have to be careful about the limits. Okay, if they have given you the joint PDF, you have to be careful about the limits, right? Okay. So by the way, what is the answer that you have got here? So it will be basically x plus y. You can either differentiate with y or x, doesn't matter. So let's suppose you're differentiating with respect to y. Okay, y is anyway 0 to 1, but and x is also 0 to 1. But basically x plus y less than or equal to 1. You have to also keep this thing into the mind, right? So y will be basically from 0 to 1 minus x, right? Okay, I mean, if you take it, y will be less than or equal to 1 minus x, right? And then x you can take freely, which is from 0 to 1. Okay, so let me just show you the solution. So if you solve this, you will be getting your answer. Okay, you just need to solve this double integration. Okay, and after you solve this, I think the answer will be, let me also paste the answer. Answer will be 1 by 3. Okay, you just have to solve this integration. Now let's move to the next question. So for this question, okay, the question that is given here, I suggest you that you first make the proper tree. Okay, see here what is happening, let me know. Here they have given you, if x is 0, then y could be 0 and y could be 1 also. They have given you the mixed tree. I mean, you just make it little simpler tree. Okay, you just do it using the tree diagram. You just make it little simpler tree. What do I mean by that? just make the proper tree. Okay, so just make this simpler tree where you will say if x is 0, okay, either x could be 0 or x could be 1. Okay, so they are asking you some probabilities, but yeah, x could be 0 or x could be 1, and then y could be 0 and y could be 1. If x is 0, then this probability is 0.2 that is given here, and if x is 1, then this probability is 0.8, right? Okay, now this probability, if x is 1, then what is the probability that by being 0? If x is 1, then what is the probability by being 0? Okay, given that x is 1, this is 1 by 7. This probability will definitely be 6 by 7. Okay, I mean automatically it will be 6 by 7. And this probability will be given as if x is 0 and y is also 0, this is 6 by 7 or this is 1 by 7. Okay, so this is 1 by 7 and this is automatically 6 by 7. This is automatically 6 by 7. Okay, so basically these probabilities are given. Now what they're asking you, the conditional probability that if the received word is y equal to 0, so they are saying if the received word is y equal to 0, y equal to 0 is received, the conditional probability that x equal to 1 was transmitted. So basically they are saying you that what is the probability that x equal to 1 was transmitted given that y equal to 0 is received. Okay, this is the only thing that they're asking. So this can be solved using the tree diagram. Understood? So let me go to the next page and let's just solve this quickly. Okay. So what is being asked is this probability of x equal to, I mean you transmitted 1 but you received 0. Given that, received 0 and transmitted 1. Okay. So how to solve this? It will be probability of x equal to 1 comma y equal to 0 divided by probability of y equal to 0. Okay. So what is this joint probability? This will be multiplication of all of this. X equal to 1, y equal to 0. X equal to 1 and y 0. This, right? 0.8 into 1 by 7 divided by 0.8 into 1 by 7 plus y equal to 0 is here also plus 0.2 into 6 by 7. Is this fine to everyone? If you solve this, you can solve this this equation. You will be getting 0.4 as an answer. Okay. Understood? Okay, PDF I will be uploading, and then you can find out the PDF of this particular session in the comment section. Okay, in the comment section you can find out the PDF. Now let's move to the next question. Okay, for this question, actually this question can be solved using the fact that if you know that rank of A transpose. Okay, we have already proved in the linear algebra rank of A transpose. Basically, we have proved the nullity. And nullity, if nullity is same, then rank will also be same, right? Because rank plus nullity is number of columns. Okay, so these things are actually same. Okay, so that is why this is the answer. Is this understood to everyone? And we have already, how many of you know that we already know this, that the non-zero eigenvalues are same of this A transpose and A transpose A? We have seen this, right, in the linear algebra. Okay, we have seen this. So in linear algebra, there was one lecture that was dedicated to this only. Maybe I can just pull out the screenshot of that lecture. Okay, but there was one lecture that was dedicated to this only, that we have non-zero eigenvalues are same, because this particular concept is very, very important. That is the only reason I just dedicated one lecture just for this. Okay. See, this particular lecture, if you notice, because there are many I can say gate PYQs that they have asked related to I mean 3-4 at least. Okay, 3-4 gate PYQs related to the eigenvalues of A, B and B. Okay, this particular lecture, which means eigenvalue of A transpose and A transpose A. I mean A, B and B. Here B is this. Okay, This is B. Eigenvalue of AB and BA. For this, we have dedicated entire lecture. Okay. I mean, that has just 37 minutes. 37 minutes lecture video. There is one video, right? So basically, eigenvalue, non-zero eigenvalues are actually same. Okay. So this is true. Since non-zero eigenvalues are same, that is why C is also true. Okay. That is why C is also true. Okay. And determinant could be different actually. That's interesting. Why? Because one of the determinant could be even zero. Okay, since non-zero is same, but zeros need not to be same. So for example, you just consider A as a matrix, or maybe you can just consider just a vector. I mean, there is no harm in considering A as a matrix which is just having one column, right? Let's suppose this is 1, 2, 3. Now, what is A transpose, or what is A transpose A? A transpose A will be basically, you will say 1, 2, 3 into 1, 2, 3. Basically, it will be a scalar, right? It will be 1 plus 4 plus 9, which is 14, right? So the eigenvalues, I mean, this is a scalar, this something like this, okay? A scalar or a matrix of 1 cross 1, okay? So it will be the eigenvalue of this A transpose A. Since A transpose is just 14, can you tell me the eigenvalue? Eigenvalue is 14 here, right? Eigenvalue is 14. Now, what is the eigenvalue of this? See here, this will be 1, 2, 3 into 1, 2, 3 like this, right? Now, if you notice, it will be a matrix actually. So it will, since the non-zero eigenvalues are same, so it will be just having one non-zero, right? Determinant of this matrix is actually 0. Okay, determinant of A transpose is actually 0. Okay, why? Because non-zeros are only same. This is 14. 14 will be the eigenvalue here only. But other two eigenvalues will be 0 and 0. So 14, 0 and 0, these are the eigenvalues here. You don't have to calculate these eigenvalues. In fact, let me just tell you, there has been gate question for this. Let me just tell you, gate CSE. There was one question, maximum eigenvalue. Actually, this concept is important, and there has been few questions related to this concept only. Let me just pull that question. Yeah, I just got that question. Okay. In GATE 2018 itself, they have asked this question. Okay. Consider this matrix. You just try out this question. B transpose, the largest eigenvalue of A. Okay. See, they're asking largest. See, A is 1, 2 into 1, 1. Okay. Into 1, 1. Something like this. So it will be a matrix. It will be a matrix. But you don't have to calculate the matrix, find out the eigenvalue. No. Because you know that whatever is the eigenvalue of UV transpose. Okay. They're asking the eigenvalue of UV transpose. Okay. Eigenvalue of UV transpose. The non-zero eigenvalues are same, right? So you just find out the eigenvalues of V transpose U. So V transpose U is very easy. 1, 1 into 1, 2. What is this? This is 1 plus 2, which is 3. Okay, V transpose U is just 3. So its eigenvalue is 3. So that is why its eigenvalue is also 3. And other eigenvalues are 0. So the largest is 3 only. Very easily, in just 30 seconds, you can solve this question. Okay, if you know the property that eigenvalues of AB and BA transpose are AB and B are same. Okay, and recently also actually many questions have been asked actually regarding this concept. Let me just tell you, I think in 2022 only trace. A trace of AB and BA. These kind of questions they have asked in 2022 only. Let me just tell you. So if you know this simple concept, you can solve many gate PYQs actually. Okay, gate CSE PYQs. See, if you know that non-zero eigenvalues of A, B and B are same, so this is true, this is true. You don't have to worry about whether it is square matrix or not, because non-zero, if non-zero is same, then summation will be same, right? Because 0 won't contribute anything in the summation. Easy question, easy question. If you know the non-zero eigenvalues, in 1 second you can just say tick tick. Okay, nothing to do, nothing to do here. Understood? So actually, this particular concept that non-zero eigenvalues are same, okay, this particular concept, okay, you can just watch this lecture. This particular concept has been asked many times in GATE. So non-zero eigenvalue, this particular line is very important. You should know this. Okay, that is why I put this in the examination. So this is true, but determinant, one of the determinant could be zero, because zero eigenvalues are not same, right? One of the determinant could be zero. Here, one of the determinant could be non-zero. So that is why this is wrong. So A, C, and D are answer here. Easy and interesting, nice question, whatever you like to say this. Okay. This is easy question, interesting question, nice question for sure. Now let's move to the next question. But let me know if you've understood this question. Okay. So in the next question, they are saying the maximum value of this determinant, okay, a real symmetric matrix with a trace 14. That's that's also interesting question. What they are saying, if you are having 2 cross 2 real symmetric matrices, then what is the determinant? Determinant will be like this, right? I mean, product of these two. Let's suppose this is A B C D. I don't want to use A B C D, but let's just use it. So basically, it will be AD minus BC. You want to maximize this, right? If you want to maximize this, you want this BC product to be 0 for sure. Okay. So basically it will be just A into D. Okay. And then trace is given as 14. Trace means A plus D is 14. So basically you can say A into 14 minus A. You want to maximize this. So basically we have seen this. Basically you want to maximize product of two things, right? X1, X2. You want to maximize X1, X2 or A into D, whatever, right? X1, X2. And it is given that X1 plus X2 is actually 14. Okay, we have solved this kind of questions also. I told you that if you want to maximize such things, I mean, you can definitely substitute, definitely differentiate. I mean, you can, one way to solve it like this, right? 14 minus X1, okay, and then differentiate with respect to X or X1. Okay, if you want to call it X, then you can call it X. But yeah, this is 14X minus 14X minus X square. And then if you differentiate 14 minus 2X, then X will be 4, X will be 7, right? X1 is 7, and then X1 is 7 and X2 is also 7, right? Both are 7. But you don't have to do all of this. Actually, I have not put this question to solve like this. I put this question to solve like this. Let me just tell you that you have to basically consider that this product should be 0. It should be just multiplication of these two, which is AD, right? Minus whatever it is, since you want to maximize, it is 0. Now the summation is actually 14. Now, whenever the summation is given and you want to you want to know that what is the maximum value of this product, then it has to be, this 14 has to be equally divided into this and this. Okay. So basically it will be 7 into 7. I mean, this 14 has to be equally divided only. Okay. This actually, anyone remember in the calculus, I told this, that it has to be equally divided like this. If you want to maximize, the product, and summation is fixed. I think when I was teaching Rolle's theorem or something, okay, at that moment I told, if anyone remember. Okay, so I actually put this question for the same reason, that if anyone remember, it is okay. Otherwise, yeah, it was an interesting question. So 49 is answer here. Okay, so if you want to maximize the product and the summation is fixed, then this thing has to be equally divided here. Otherwise, you can definitely do like this. But yeah, I want you to just quickly do it. Okay. Great. Now let's move to the next question. Yeah, this was related to linear algebra, right? This was LA question. In LA, we have seen this thing, that if you have distinct eigenvalue, then it will definitely implies linearly independent eigenvectors. Right? But other way is not true. This is not true. So basically, this way is true. Okay. So S2 definitely implies S1. But S1 cannot imply S2. We have seen this. Okay. If you are having independent eigenvectors, then it doesn't mean that eigenvalues will be distinct, right? So basically, for lambda equal to, let's suppose 1, you can have two independent eigenvectors, let's suppose E1 or E2, okay, or something like this. So basically, if eigenvectors are independent, doesn't mean that lambda values are also distinct. So it is not other way. So S2 implies S1. Now, having it singular or non-singular or invertible or non-invertible doesn't tell anything about the eigenvectors or eigenvalues. Okay, I mean, it can only say that lambda equal to 0 is one of the eigenvalue or not. Okay, apart from that, you cannot conclude anything whether the eigenvectors are linearly independent or not linearly independent. So if matrix is invertible, this information can just tell only one thing, okay, about the eigenvalue, which is lambda equal to 0 is there. Whether the eigenvectors are independent, you don't know. Whether there are multiple lambda equal to zeros, you don't know. Okay, so only tells one thing. That can only tell you one thing, that lambda equal to 0 exists. Understood? Yeah, non-singular means invertible. Okay, it can be invertible. Singular means actually, yes, this is, I don't know if it is, confusing you or little counterintuitive. Singular means you cannot invert it. Non-singular means you can invert it. Invertible means A inverse exists. Inverse, okay, it can be invertible. Now let's just solve this question. Here they are saying that which of the following statement about the vector space and the linear transformation is or are correct. This was MSQ question. Okay. So what was your answer of this question? Can you tell me? What was your answer of this question? Yes, for this actually A, B, C, D all are correct, right? So let's just check. Let's just check each options one by one. So if V is in the span, okay, let's suppose W and A are spanning some space, and then V is in that span, and W is in the span of A and B. Okay, W already is in the span of A and B, right? And V is in the span of AB and A, okay, which means V is automatically in the span of AB, right? I mean, that's trivially true. Okay, so if you have AB and A, I mean, V is in a span of AB, so that's very much, I mean, can be seen here. Okay, AB and A, so B is in a span of AB and A, so it means V is in a span of AB. If V and W are n-dimensional vector space, there exists a linear transformation such that it is both 1 1 and on 2, which means this is bijective. So we have seen many examples, right? I mean, there are if the matrix is invertible, then corresponding T is bijective, right? Okay, in the sense that if you have bijection, or maybe the question is basically, then that there exists some bijections, right? So actually you can definitely have the bijection. I mean, there is no problem in having the bijection. So this is very trivial option. So you can have bijection, you can have injection, you can have, you can have 1 1 only, you can have on 2 only, like that, right? You can have surjective functions. Okay, so bijection means like 1 1 and on 2 both combinedly is called bijection. Okay, if V is n-dimensional vector space, then every linearly independent subset of V contains at most n vectors. Yes, if it is linearly independent, then obviously basis, since the basis is having at most n, then any linearly independent will be having at most n, right? I mean, it cannot have, how it can have more than n if it is just n-dimensional space, right? Now they are saying that is the standard matrix of T, then TB is the matrix of T with respect to the another basis, then determinant of T and determinant of TB are same. So basically both are related by like this. See, determinant, I mean, T and TB are related like this. So there will be some matrix and T and TB related like this, right? So basically you can say, if you find out the determinant, then this will be determinant of 1 by P, then determinant of TB, and then determinant of P, and then this is 1 upon determinant of P. So this will get cancelled out, and this determinants are actually same. Actually you can say these are the similar matrices, right? These are the similar matrices. So their eigenvalues will be same, their determinants will be same. Okay, I mean, similar matrices is one of the concept here that we have seen. Okay, so that is why all the options are correct here, A, B, C, D. Okay, now let's just see this question. In this question they are saying, if they are linearly independent already, then after multiplying a matrix, T is a linear transformation means multiplying a matrix, then also they are linearly independent? No, if the matrix itself is 0, right? It is very trivial example. Then you will be having all these are 0. Then are they linearly independent? Definitely no, right? So it's not true. It's not true. They are not linearly independent. But the other way is true. So other way is saying, if they are, I mean, after transformation, after the matrix, let's suppose AB1, AB2, these are linearly independent. Okay. these are linearly independent, then it implies that v1 v2 vn, these are also linearly independent. Okay, so how to prove it? Let's just check. See, the proof, we want to prove that t v1 t v2, okay, t vn, if these are linearly independent, then we want to prove that v1 v2 vn, these are linearly independent. Understood? Okay, suppose I will be proving using the contradiction basically. Okay, so suppose these are not linearly independent. I mean, there are like t2 v2 cn vn equal to 0. Okay, I mean, let's suppose this equation exists, which means suppose v1 to vn are not linearly independent. Okay, now if you take linear transformation both side, it will be c1 c v1 plus c2 t v2, like this, right? If you take linear transformation both side. Now, since you know that these are linearly independent, so that is why C1, I mean, they all have to be 0, right? You know the linearly independent condition. I mean, for this equation, all has to be 0 if these are linearly independent, right? If some vectors are linearly independent, then these all have to be 0 at the same time. There cannot be non-zero for this equation. Okay. So from this, since we know, okay, given the fact, right? Given the fact that these are linearly independent, for this I can say C1, C2 all are 0. Right? If all are 0, then our initial assumption that these are not linearly independent, this is false. Or in other words, you can say the only solution exists which are all are 0. So basically, for this equation also, the only solution exists which are all are 0. So they have to be linearly independent. Okay, they cannot be linearly dependent. They are not linearly dependent. I mean, you can prove it by contradiction. Okay. Now let's move to the next question, which is I think one of the last question. So they're asking about, this was MSQ question. They were asking about the subspace. Okay. Since this is, I mean, this is homogeneous. Okay. This is like x1 or x, if you take x, y, z, x minus 3 y equal to 0. I mean, these are homogeneous equations, right? For the homogeneous equations, we know there's a vector space. Now, if you check this, this is because of the plus 2, this is heterogeneous or non-homogeneous, right? So that's why this is not a vector space. Now here, zero vector it doesn't contain 0. 0 doesn't lie in W3. It doesn't contain 0. 0 vector is not there. So that is why this is not also true. This is not a vector space, right? And for these kind of things, okay, most probably these are not vector space, but you can anyway prove that for 3 numbers, okay, a1, a2, a3, or for one vector that belong here, for another vector that belong here. So basically, you can do 2 vectors that belong to this, okay? And it will not satisfy, most probably it will not satisfy the closure. You can take any 2 vectors that belong to this. For belong, it has to satisfy this condition, which is 5a1 square minus 3a2 square minus 6a3 square equal to 0. I mean, you have to select a1, a2, a3 such that these 3 are satisfied, a1, a2, a3, such that this condition is satisfied basically, right? If you take these some numbers, I actually have those numbers if you want, but I need to just check in the doc. If you want, I can just bring those numbers for you. But yeah, you can have any 3 numbers which are satisfying this, any other 3 number which are satisfying this, put it here. You will check that if you add these 2, then the addition, obviously there is no I mean reason to for the addition to satisfy. For example, if this is 1, this is, let's suppose, 3, this is okay, this is, let's suppose, 4, 5, this is, let's suppose, 6, 9. Obviously it is not satisfying this equation, it might not be satisfying this equation, but for now let's just assume it is satisfying. I mean, it is belonging to W3, it is belonging to W3. Then obviously 1 plus 3, 4 plus 6, I mean this particular, okay, these 3 numbers, whatever we will be getting, it will not satisfy this equation, because these are the plus, okay, just a normal addition, and there is no way it will be satisfying the squared. Okay. So by the way, these numbers I'm erasing because these numbers might not belong to W4. So that is why you will say this is also not the correct answer. Okay, this is also not the correct answer. Why this option is wrong? Okay, because this option is wrong because this is non-homogeneous. And we have seen for the solution of non-homogeneous, it is always some constant vector plus some vector space. Okay, so just see solution of how to solve linear equations. Okay, if I just give you x equal to y plus 3, let's suppose, and I give you like this. Okay, x equal to z plus 2. Let's suppose I give you these two equations. If you solve these two equations, then you will first write like this. Okay, then you will be making a matrix of this, right? X is 1, y is minus 1, z is 0, x is 1, y is 0, z is minus 1, and 3 2. You will be making augmented matrix of this. Then you will be finding the solution of this, right? Solution of this. Then the solution will look like this. Okay, solution will be looking like this. Let me just tell you. If this is non-homogeneous, solutions will look like this. It will look like, okay, that x, y, z will look like some constant vector plus some vector space. Okay, I mean, because of this constant vector, okay, the 0 does not belong to this, or maybe you can directly see, okay, the 0 does not belong to this w2. Okay, 0 does not belong to this w2. You can directly see like this, or maybe, I mean, actually in my mind it is fit that, okay, for non-homogeneous, it is not a vector space because of the constant vector. Okay, or in other words, you can say 0 does not belong to this. Okay, so yeah, that is the complete solution. So that's all. Okay, and then then I think you have understood all of those concepts or all of those questions that we have discussed here. And then we will be basically having AIMT 4. Okay, that has already been announced in one of the YouTube shorts, but I will just make another video for AIMT 4. We will be having that on 25th of January. Okay, so best wishes for this. And if you are liking, okay, the detailed solution that we are providing, okay, detailed solution that we are providing, if you're liking those, then just let us know in the comments. Okay, so that we are more motivated that, okay, we will be providing a detailed solution for all other AIMTs also. Okay, if there is any other question, like you're asking like how to revise and all, you can just let me know in the comments. Okay, and then I will be replying. Okay, just let me know in the comments if there is any question that you have. Okay, so thank you everyone. I hope you really liked this session, and if you actually liked it, then just let us know in the